close your eyes and imagine the red planet glowing in the night sky above you. Mars has captivated humans for centuries with its mysteries and wonders. Tonight, let these amazing facts about our neighboring world gently guide you into peaceful sleep. The red planet got its name from the Roman god of war, and honestly, it makes perfect sense. Ancient Romans looked up at the night sky and saw this blood-red dot moving against the stars, and their first thought was basically, yep, that's definitely the god of war up there. Can you blame them? But here's what's fascinating. Every civilization that spotted Mars had the same reaction. The ancient Greeks called it Ares, their own war god. Sanskrit speakers named it Mangala, meaning the burning one. Arabs called it Al-Mirik, the burning one. Again, notice a pattern? Apparently, seeing a red object in the sky just screams violence and fire to humans across all cultures. Ancient astronomers took this connection seriously. They believed Mars's movements predicted wars and bloodshed. When Mars appeared brighter or moved in certain directions, generals would literally change their battle plans. Imagine calling off an invasion because a planet looked a little too close to the moon that night. The Babylonians tracked Mars for over 4,000 years, creating detailed charts of its wandering path. They called it the Wanderer, because unlike regular stars, Mars seemed to have a mind of its own, sometimes stopping, backing up, then moving forward again. Well, there's something even stranger about this red planet that ancient astronomers never could have guessed. When you look at Mars through a telescope, that rusty red color practically screams at you. But here's something that'll mess with your head. If you were actually standing on the Martian surface, you'd barely see any red at all. The whole red planet thing is basically a cosmic optical illusion. All that iron oxide, fancy name for rust, floating around in Mars's atmosphere creates this reddish haze when viewed from Earth. It's like looking at someone through rose-colored glasses, except the glasses are made of literal rust particles. Step foot on Mars, though. You'd find yourself surrounded by colors that look more like a desert road trip through Arizona. We're talking butterscotch, golden tan, and even patches of greenish rock. The soil beneath your boots would range from dark chocolate brown to pale yellow, depending on where you landed. The atmosphere plays the ultimate magician here. Dust storms can shift the color palette dramatically across different regions. Some areas look almost golden during certain seasons, while others maintain that familiar rusty appearance. It's like Mars has multiple personalities, each with its own color scheme. NASA's rovers have captured thousands of images showing these true colors, and honestly, they're way more beautiful than that monochrome red we've been picturing for centuries. But Mars has even bigger surprises waiting, including a mountain so massive it defies belief. When you think about massive volcanoes, Mount Everest probably comes to mind as something impossibly tall. Well, Mars just laughed at that and said, "Hold my space beer." Olympus Mons towers 13.6 miles into the Martian sky. That's 3 times taller than Everest. But here's where it gets absolutely ridiculous. This monster volcano covers an area the size of Arizona, the entire state. You could literally fit the whole state of Arizona inside this single volcanic mountain. How does something this enormous even form? Mars has weaker gravity than Earth, which means volcanic material can pile up much higher before collapsing under its own weight. Plus, Mars doesn't have moving tectonic plates like Earth does. When a volcano starts erupting in one spot, it just keeps building in that exact same location for millions upon millions of years. Think about it this way. On Earth, our volcanoes eventually move away from their magma sources because the continents drift around. But Olympus Mons just sat there like a patient giant, growing taller and wider with each eruption over geological time. The slopes are so gradual that if you were walking up this mountain, you might not even realize you're climbing the largest volcano in the solar system. The incline is only about 5 degrees in most places. But speaking of time, here's something that might surprise you about Mars. Here's something that'll make you smile. A day on Mars lasts 24 hours and 37 minutes. That's basically identical to Earth. What are the odds? Out of all the planets we could have picked to obsess over, we chose the one that matches our sleep schedule. It's like the universe planned this cosmic coincidence just for us. This similarity isn't just neat trivia. It's actually huge for mission planning. NASA doesn't need to completely reprogram their team's biological clocks. Rover operators can work somewhat normal shifts, though they do have to adjust by those extra 37 minutes each day. Over time, it creates this weird drift where Mars mission teams slowly shift out of sync with Earth time. Future astronauts will love this. Their circadian rhythms won't get completely demolished like they would on Venus, where a day lasts 243 Earth days. Can you imagine trying to sleep through that? The discovery happened way back when astronomers first started timing Mars through telescopes. They expected something wildly different. Instead, they found our planetary neighbor keeping almost perfect time with us. But here's where Mars gets really weird with time. While the days match up perfectly, the years tell a completely different story. Mars has 2 moons, but calling them moons feels almost generous. Phobos and Deimos look more like giant potatoes tumbling through space than the bright round moon we're used to seeing from Earth. Discovered back in 1877 by astronomer Asaph Hall, these lumpy companions got their names from Greek mythology. Phobos means fear, and Deimos means panic. Fitting names for the sons of Ares, the Greek god of war. Makes sense, right? Even Mars's moons sound intimidating. But here's where it gets wild. Phobos zips around Mars 3 times every single day. While our moon takes 28 days to orbit Earth once, this speedy little rock completes an entire orbit in just 7.5 hours. If you lived on Mars, you'd watch Phobos rise in the west and set in the east, backwards, compared to everything else in the sky. Deimos moves more normally, but still twice as fast as our moon. Both moons are tiny. Phobos stretches only 14 miles across at its widest point. You could drive across it in 20 minutes. Deimos is even smaller at just 8 miles wide. Most scientists think these aren't real moons at all, but captured asteroids that got trapped by Mars's gravity millions of years ago. They're just cosmic hitchhikers. Speaking of time, though, Mars itself follows a completely different calendar than we do. While Earth circles the Sun in a neat 365 days, Mars takes its sweet time. 687 Earth days to complete one orbit. That's nearly twice as long as our year. This means if you celebrated your birthday on Mars, you'd only get a party every 22 months by Earth standards. Talk about making birthdays feel special. Your 10th birthday would actually be when you're 18 on Earth. Suddenly, those childhood years seem much longer, doesn't they? But here's where things get really interesting for future Mars explorers. Those extended seasons create weather patterns that make Earth look predictable. Spring on Mars lasts about 7 months. Summer stretches for 6 months. Fall drags on for 5 months, while winter feels endless at 7 months. The southern hemisphere gets hit particularly hard. When Mars swings farthest from the sun during southern winter, temperatures plummet even more dramatically than usual. We're talking about differences that make Antarctic winters seem cozy. Mission planners have learned to work around this cosmic calendar. Launch windows between Earth and Mars only open every 26 months, when the planets align favorably. Miss your ride, and you're waiting over 2 years for the next opportunity. Speaking of water on Mars, those long seasons play a crucial role in something even more remarkable about the red planet's past. Picture this. Mars wasn't always the dusty, barren world we see today. Billions of years ago, it was practically an alien version of Earth, complete with massive oceans that would make our planet jealous. We're talking about water bodies larger than Earth's entire Arctic Ocean. That's roughly 4 million square miles of liquid water sloshing around Mars's northern plains. The evidence is everywhere if you know where to look. Ancient shorelines carved into rock formations tell the story. Dried up riverbeds snake across the surface like fossilized highways. Delta formations sit frozen in time, exactly where rivers once dumped sediment into vast seas. It's like walking through a museum of what Mars used to be. But here's what blows my mind. This wasn't just a puddle that lasted a few years. These oceans existed for hundreds of millions of years, long enough for complex chemistry to happen, long enough for who knows what to evolve in those ancient waters. The northern hemisphere was basically one giant sea. Imagine standing on ancient Mars, watching waves crash against rocky shores under that butterscotch sky. The southern highlands would have been like massive continents rising from the water. Then something catastrophic happened. The atmosphere got stripped away, and all that water just vanished into space. Speaking of vanishing acts, wait until you discover what Mars's weird gravity would do to your body. Forget everything you thought you knew about athletic performance. Mars would turn you into a superhuman athlete overnight. With gravity only 38% of Earth's, your body weight drops by more than half. That 150-pound frame suddenly feels like 57 pounds. Your muscles, trained for Earth's crushing pull, become rocket boosters in Mars's gentle embrace. Jump off a Martian cliff, you'd soar 20 feet into the butterscotch sky. A casual hop becomes a superhero leap. Basketball players would slam dunk from the free throw line. High jumpers could clear buildings. But here's where things get weird. Your muscle mass stays the same while resistance vanishes. It's like having superpowers with a hidden catch. Every step becomes a potential moon bounce. Walking normally requires conscious effort to stay grounded. Running turns into a series of gentle bounds across the rusty landscape. You'd need weighted boots just to feel normal. The real kicker. Your bones and muscles would love this vacation initially, but they'd start weakening within weeks. Without Earth's constant gravitational resistance, your skeleton begins losing density. Your heart muscles shrink from pumping against lighter loads. Athletes training for Mars would need revolutionary exercise equipment just to maintain basic human strength. Imagine treadmills with pulleys yanking you downward. Speaking of Martian challenges, the weather patterns up there make Earth's hurricanes look like gentle breezes. Picture this. You're watching the weather forecast, and the meteorologist says a dust storm will cover your entire continent for 6 months straight. Sounds impossible. Well, on Mars, that's just Tuesday. Martian dust storms make Earth's hurricanes look like gentle breezes. These cosmic tantrums can engulf the entire planet, turning day into night for months on end. The 2018 storm was so massive it essentially murdered the Opportunity rover by blocking out all sunlight to its solar panels. Poor little guy had been chugging along for 15 years, and then lights out. But here's what blows my mind. These storms start from almost nothing. A tiny whirlwind picks up some dust, which heats up in the sunlight, which creates more wind, which picks up more dust. It's like planetary road rage that just keeps escalating until half the solar system is watching Mars throw its dusty tantrum. The dust particles are finer than talcum powder and carry enough static electricity to fry electronics. Imagine trying to do laundry in a washing machine filled with angry, electrified flour. That's basically what rovers deal with during these storms. Speaking of Mars looking different than expected, wait until you hear about what color the sky actually is during a normal day. Looking up at the Martian sky during the day would feel like staring through butterscotch candy. That warm, golden hue dominates everything above you, creating an alien landscape that's both beautiful and unsettling. The thin atmosphere scatters light completely differently than Earth's thick blanket of air. While our planet's atmosphere bounces blue light around like a pinball machine, Mars barely has enough gas to scatter anything properly. The result? A sky that looks more like caramel than the brilliant blue we're used to. But here's where Mars gets really weird. Sunsets turn blue, the exact opposite of what happens on Earth. When the sun dips toward the horizon, that butterscotch fades into a stunning blue glow around the solar disk. It's like someone flipped a cosmic switch and reversed the rules of physics. The dust suspended in the atmosphere plays a huge role too. Those tiny rust particles floating around act like a permanent filter, warming up the daylight colors. Think of it as Mars wearing permanent amber-tinted sunglasses. Astronauts living there would wake up every morning to this golden world. No brilliant blue to remind them of home. Just that endless butterscotch dome stretching to every horizon. The psychological impact of never seeing a blue sky again might be tougher than we realize. Speaking of Mars defying expectations, wait until you discover the massive scar that dominates its entire surface. Picture the Grand Canyon, then multiply it by sheer absurdity. Mars has a canyon system called Valles Marineris that makes our Earth landmark look like a sidewalk crack. This Martian monster stretches 2,500 miles across the planet's surface. That's like a canyon running from New York to Denver without taking a single break. But wait, it gets more ridiculous. The thing is 4 miles deep and 125 miles wide at its broadest point. You could literally fit the entire continental United States inside this geological beast with room to spare for a few extra states. Talk about having space issues. What's truly mind-blowing is how this canyon probably formed. Unlike our Grand Canyon, which took millions of years of patient water erosion, Valles Marineris likely ripped open when Mars was still geologically active. The planet's crust literally tore apart like someone unzipping a cosmic jacket. Some sections may have been carved by ancient floods, but most of it, pure planetary violence. The canyon system is so massive that if you stood on one rim, the other side would be beyond the horizon. You'd need binoculars just to see across to the other edge. And here's something that'll make you question everything you thought you knew about planetary weather patterns. If you thought Martian dust storms were the biggest problem for future astronauts, Wait until you hear about what's actually in the soil beneath their feet. The rusty red dirt that makes Mars look so beautiful from space, it's basically trying to kill you. Martian soil contains chemicals called perchlorates at levels that would make a chemistry teacher faint. We're talking about concentrations around 0.5%. That might sound tiny, but it's roughly 10,000 times higher than what we find in Earth's driest deserts. To put this in perspective, eating just a handful of Martian dirt would send you straight to the emergency room. But here's where it gets really frustrating for future Mars farmers. These perchlorates don't just sit there looking pretty. They actively destroy organic compounds and can seriously mess with your thyroid if you're exposed to them. Remember Matt Damon growing potatoes in The Martian? Well, he would have needed to wash that soil more thoroughly than a germaphobe washing their hands during flu season. The good news? Scientists have figured out ways to remove these toxic chemicals through various washing and heating processes. The bad news? You'll need to treat basically every speck of soil before you can even think about growing a single tomato. Speaking of growing things, the challenges don't stop at toxic soil. Mars has polar ice caps that would make Earth's look pretty boring by comparison. While our planet just has regular old water ice sitting at the poles, Mars decided to get creative with its frozen headwear. The North Pole is basically a giant water ice cap. Nothing too shocking there, right? But here's where Mars shows off its flair for the dramatic. The South Pole? That's a wild cocktail of both water ice and carbon dioxide ice. Yeah, frozen carbon dioxide. We call it dry ice down here, and it's the stuff that makes those cool smoky effects at concerts. During Martian winter, the South Polar Cap grows like crazy as more carbon dioxide freezes out of the atmosphere. Then spring arrives, and things get interesting. The dry ice doesn't melt like regular ice would. Instead, it sublimates directly from solid to gas, skipping the liquid phase entirely. Talk about efficiency. The really cool part is what these ice caps tell us about Mars's climate history. Those layers of ice stack up like pages in a history book, recording thousands of years of atmospheric changes. Each stripe represents different climate conditions, dust storms, and seasonal variations. The North Cap stays pretty stable year-round, but watching the South Cap grow and shrink is like watching Mars breathe. And speaking of breathing, the way this planet handles its atmosphere will absolutely blow your mind. Picture this. After decades of failed attempts and crashed landers, humanity finally pulled off something incredible in 1976. The Viking 1 and Viking 2 missions didn't just reach Mars. They actually survived landing on its surface. Before Viking, Mars missions were basically expensive fireworks shows. The Soviets tried repeatedly, but their landers either crashed or went silent within seconds. Then NASA stepped up with twin Viking orbiters and landers, each weighing as much as a small car. The landing process was absolutely bonkers. These spacecraft had to slow down from 17,000 miles per hour to 0 in just 7 minutes. They used parachutes, retro rockets, and landing legs, basically throwing everything at the problem until something worked. But here's what blew everyone's minds. The first photos from the Martian surface looked surprisingly normal. Rocky, yes. Alien, sure. But not the bizarre landscape people expected. It looked like a really harsh desert, maybe Arizona on a particularly bad day. Viking's most ambitious experiment tried detecting life by feeding Martian soil nutrients, and watching for biological responses. The results? Frustratingly inconclusive. The soil reacted, but probably due to weird chemistry rather than little green microbes. These missions operated for years longer than planned, fundamentally changing how we see our planetary neighbor. Speaking of seeing Mars differently, wait until you hear about the weather reports these robots started sending back. When you think of Mars, snow probably isn't the first thing that comes to mind. Well, Mars actually has some pretty wild weather patterns, including real snow falling from alien skies. But here's where it gets weird. Mars doesn't just have one type of snow. It has two completely different kinds. Water snow falls just like on Earth, except it usually evaporates before hitting the ground because the atmosphere is so thin. It's like nature's ultimate disappearing act. Then there's dry ice snow. Yeah, frozen carbon dioxide literally falls from Martian clouds. This stuff is cold enough to freeze your eyeballs. We're talking negative 125 degrees Celsius. The crazy part? This dry ice snow actually makes it to the surface, especially near the polar regions. Mars also experiences some pretty intense seasonal changes. Summer temperatures at the equator can reach a toasty 20 degrees Celsius, which honestly sounds like a nice spring day. But winter? Try negative 143 degrees Celsius at the poles. That's cold enough to freeze the atmosphere itself. The planet even has its own version of weather fronts, complete with swirling cloud formations that would make Earth meteorologists jealous. These weather systems can span entire continents and last for weeks. Speaking of lasting for weeks, there's something else about Mars that ancient astronomers noticed thousands of years ago. Billions of years ago, Mars wasn't the thin-air desert we know today. It had a thick, cozy atmosphere that could actually hold on to heat. Think Earth's atmosphere, but on Mars. Pretty wild, right? Here's what happened. Early Mars was like that friend who had everything going for them, but slowly lost it all. The planet started with an atmosphere potentially 10 to 20 times thicker than what exists today. That thick blanket of gases created a greenhouse effect, trapping heat and keeping temperatures warm enough for liquid water to flow freely across the surface. But then Mars hit the cosmic lottery in the worst way possible. Without a strong magnetic field to protect it, solar winds started stripping away that precious atmosphere, molecule by molecule. It's like having your house's roof slowly blown away during a decades-long hurricane. Scientists figured this out by studying isotope ratios in the current Martian atmosphere. The lighter isotopes escape to space more easily, leaving behind heavier ones as evidence of this atmospheric robbery. The MAVEN spacecraft has actually watched this process happening in real time, measuring how much atmosphere Mars loses every single day. The loss wasn't quick either. It took roughly 4 billion years of steady atmospheric bleeding to reach today's whisper-thin air. Speaking of that current atmosphere, there's something fascinating about how Mars behaves differently from Earth in another way. Just like Earth has seasons because it tilts on its axis, Mars does the exact same thing. The red planet leans at 25 degrees, which is surprisingly close to Earth's 23.5-degree tilt. This might sound boring, but it's actually what makes Mars feel almost like home. When Mars tilts toward the sun, that hemisphere gets summer. Tilt away? Winter arrives with a vengeance. The northern ice cap shrinks during summer and grows massive during winter, just like our Arctic ice. But here's where Mars gets weird. Its axis doesn't just tilt, It wobbles like a spinning top that's losing steam. This wobble happens over thousands of years and completely changes the planet's climate. Sometimes Mars tilts so far that its poles point almost directly at the sun. Imagine if Earth did that. The ice caps would melt entirely, and the atmosphere would get thicker from all that extra water vapor. During other wobble periods, Mars tilts so little that its poles stay frozen year-round, locking up water and making the atmosphere even thinner. These dramatic tilt changes explain why Mars looks so different today compared to billions of years ago, when rivers flowed across its surface. The wobbling also creates these incredible layered ice formations at the poles, like geological history books written in frozen water. But speaking of things flying through space and landing in unexpected places, when scientists discovered chunks of Mars sitting in museums and private collections on Earth, nobody believed it at first. Sounds impossible, right? Well, the largest confirmed Martian meteorite weighs a whopping 40 pounds and has been sitting on our planet for thousands of years. Here's how this cosmic delivery system works. Massive asteroid impacts on Mars occasionally hit with such incredible force that they launch rocks completely off the planet's surface. We're talking about explosions that make nuclear bombs look like firecrackers. These Martian rocks then spend millions of years drifting through space before eventually crash landing on Earth. The crazy part, we've found over 200 confirmed Martian meteorites so far. Each one is like getting a free sample package from Mars, delivered express by the solar system itself. Scientists can tell they're from Mars by analyzing trapped gases inside the rocks that perfectly match the Martian atmosphere composition measured by our rovers. One famous meteorite called ALH 84001 even sparked debates about ancient Martian life when researchers thought they spotted fossilized bacteria inside it. Though that claim remains controversial, these meteorites continue revealing secrets about Mars's geological history, ancient climate, and chemical composition. But Mars isn't the only planet that experiences these cosmic impacts, creating unusual atmospheric phenomena. Despite lacking a global magnetic field like Earth's, Mars still manages to put on its own light show, with auroras dancing across its rusty skies. These aren't your typical northern lights, though. Earth's auroras happen because our planet's magnetic field acts like a giant funnel, channeling charged particles from the sun toward our poles. Mars lost its global magnetic field billions of years ago, yet somehow it still creates these ethereal displays. The secret lies in patches of ancient magnetism scattered across the Martian surface like cosmic fingerprints. These leftover magnetic zones are remnants from when Mars had a proper magnetic field, back when it was a much more hospitable world. Think of them as magnetic fossils embedded in the crust. When solar wind particles slam into these localized magnetic pockets, they create auroras that can appear anywhere on the planet, not just at the poles. The Mars Express orbiter first spotted these ghostly green glows in 2005, completely baffling scientists who thought auroras were impossible without a global magnetic field. These Martian light shows are typically green, caused by oxygen atoms getting excited by incoming particles. What makes this discovery even more fascinating is what it tells us about Mars's magnetic past. But the real surprise comes when you realize how long these ethereal sunsets actually last compared to our own planet's fleeting twilight moments. When you watch a sunset on Earth, you get maybe 15 to 20 minutes of twilight before darkness falls. But on Mars, you'd have nearly twice as long to enjoy the show. The thin Martian atmosphere creates this extended twilight period because there's less air to scatter sunlight. Earth's thick atmosphere quickly absorbs and redirects light once the sun drops below the horizon. Mars doesn't have that luxury. With an atmosphere only 1% as dense as Earth's, light can travel much further through it before finally fading away. And here's something that would blow your mind if you were standing on Mars watching this happen. The sunset itself appears blue. While Earth gives us those gorgeous red and orange sunsets, Mars flips the script completely. The rusty dust particles in the Martian atmosphere scatter red light throughout the day, leaving the blues and greens to shine through when the sun is low. Picture this romantic scenario. You and your partner watching a pale blue sun slowly sink behind alien mountains, followed by 40 minutes of gentle twilight painting the butterscotch sky in soft pastels. Not bad for a planet that's supposed to be dead and barren, right? These extended twilight periods would actually be pretty useful for future Mars colonists, giving them extra time to work outdoors before the brutal cold sets in. Speaking of brutal conditions, ancient Mars had flowing rivers that make today's Amazon look tiny. Mars wasn't always the dry, dusty world we see today. Billions of years ago, ancient rivers carved intricate valleys across its surface, creating networks that would make the Mississippi jealous. These weren't tiny streams either. We're talking about massive waterways that meandered for hundreds of miles. The evidence is written in stone, literally. Satellite images reveal branching patterns that look exactly like river deltas on Earth. You know those gorgeous aerial shots of the Nile Delta? Mars has similar formations, except they're fossilized in time. Some of these ancient riverbeds are so well preserved, you can trace their path from source to what were once vast lakes. Here's what blows my mind. These rivers didn't just flow for a few thousand years. They carved and recarved their channels over millions of years, suggesting Mars had stable, flowing water for incredibly long periods. That's not a quick flash flood. That's a sustained, Earth-like water cycle. The most impressive examples sit in places like Eberswalde Crater, where you can see a delta formation so clear it looks like someone drew it with a textbook. The sediment layers tell stories of seasons, floods, and gentle flows that deposited materials just like rivers do today. But here's the real mystery. Where did all that water go? Well, that leads us to something even more fascinating about Mars's seasonal behavior. Picture Mars during its spring season, and you'll witness something absolutely fascinating. The equator becomes a cleaning frenzy zone. But we're not talking about Martian janitors with brooms. Dust devils everywhere. These spinning columns of air become Mars's natural housekeeping crew. They form when the planet's surface heats up, creating perfect conditions for these mini tornadoes to dance across the landscape. The best part? They're actually helpful. NASA's rovers have experienced this Martian spring cleaning firsthand. Spirit and Opportunity got their solar panels mysteriously cleaned when engineers expected them to die from dust buildup. Engineers were scratching their heads until they realized dust devils were doing the work for free. Talk about cosmic customer service. These cleaning crews can reach heights of 5 miles. That's like a tornado made of helpful intentions. The spinning action creates static electricity that literally lifts dust particles right off equipment surfaces. It's nature's vacuum cleaner, Martian style. The timing isn't random either. Spring brings temperature changes that create perfect atmospheric conditions. Warm air rises from heated ground. Cooler air rushes in, and boom, you've got yourself a dust devil cleaning service that never sends a bill. Without this natural phenomenon, many Mars missions would have ended much sooner. Sometimes the planet that wants to kill you also wants to help you survive. But Mars has even more mysterious underground features that could provide the ultimate shelter. Deep beneath the Martian surface lies a network of caves that could become humanity's first extraterrestrial neighborhoods. These aren't just tiny holes in the ground. We're talking about massive lava tubes stretching for miles underground, some large enough to fit entire city blocks. When ancient volcanoes on Mars erupted billions of years ago, flowing lava created these natural tunnels. The outer layer of lava cooled and hardened, while the inner molten rock kept flowing, leaving behind hollow tubes. It's like nature built underground highways, specifically for future space explorers. The best part? These caves offer perfect protection from Mars's biggest threats. Radiation that would fry you on the surface can't penetrate through feet of solid rock. Temperature swings that range from tropical to Antarctic happen daily on the surface. But inside these caves, it's a steady, manageable cool. Mars has thousands of these underground shelters scattered across the planet. Some are so large that entire football stadiums could fit inside with room to spare. The entrance holes we've spotted from orbit are just the tip of the iceberg, or should I say, tip of the lava tube. Finding these caves was like discovering ready-made apartment buildings on an alien world. No construction required, just move in and start decorating. But exploring these underground mansions presents its own unique challenges. Back in 1996, scientists found something that made the entire world stop and stare. A meteorite called ALH-8 4001, blasted off Mars millions of years ago, contained tiny structures that looked suspiciously like fossilized bacteria. These microscopic formations were so small you'd need a powerful electron microscope just to see them. The rock itself was ancient beyond belief. 4.5 billion years old. That's older than most of Earth's surface. When researchers sliced it open, they discovered orange-colored carbonate minerals that could only form in the presence of liquid water. But here's where things got really wild. Embedded within those minerals were worm-like structures, perfectly preserved. They were about 100 times smaller than bacteria on Earth, yet they showed all the characteristics of biological remains. The shapes were too organized, too purposeful to be random mineral formations. NASA held a press conference that sent shockwaves around the globe. President Clinton even made a statement about the discovery. The scientific community erupted into heated debates that continue today. Some researchers remain convinced these are genuine Martian fossils, while others argue they're just unusual mineral crystals. The controversy hasn't killed the excitement, though. If anything, it's made scientists more determined to find definitive proof of life beyond Earth. Speaking of Martian landscapes, there's one particular region that's become famous for an entirely different reason. Ever heard of Acidalia planitia? This massive triangular region on Mars became famous when Matt Damon grew potatoes there in The Martian. But here's what Hollywood didn't tell you about this place. Acidalia planitia stretches across 2,000 miles of northern Mars, making it roughly the size of the entire continental United States. The name sounds fancy, but it literally means acidic plain, though ironically, The soil isn't particularly acidic at all. Ancient astronomers just thought it looked brownish red through their telescopes. What makes this region special isn't just its Hollywood fame. These plains are smoother than a bowling ball. We're talking about terrain so flat that NASA engineers practically drool over it when planning landing sites. The smoothness comes from billions of years of dust settling and ancient water flows that leveled everything out. The real Acidalia planitia sits in what scientists believe was once an ancient ocean basin. Those perfectly flat areas, they're essentially the dried-up seafloor of Mars. Walking across them would feel like strolling through the world's largest parking lot, except with butterscotch-colored dust instead of asphalt. But here's where reality beats fiction. While Mark Watney battled massive dust storms in the movie, real Acidalia planitia is surprisingly calm. The high atmospheric pressure there reveals something fascinating about how Mars actually breathes. When you think about breathing on Mars, forget everything you know about taking a deep breath. The Martian atmosphere is 95% carbon dioxide. That's like trying to breathe inside a giant soda bottle. Earth's atmosphere? 21% oxygen, 78% nitrogen. Mars flipped the script completely. The remaining 5% of Mars' atmosphere includes tiny amounts of nitrogen, argon, and trace gases. But here's what makes it truly bizarre. The entire atmosphere is thinner than what you'd find 22 miles above Earth's surface. This creates some wild situations. Water boils instantly on the Martian surface because there's not enough atmospheric pressure to keep it liquid. Your blood would literally bubble if you stepped outside without a pressure suit. Makes sense, right? The carbon dioxide concentration also means that even if Mars had thicker air, you still couldn't breathe it. You'd pass out from carbon dioxide poisoning before lack of oxygen got you. It's like being trapped in a room with a broken furnace. But wait, there's something even stranger about this atmospheric cocktail. The thin air means weather patterns behave completely differently than on Earth. Dust storms can rage for months because there's less atmospheric friction to slow them down. Speaking of those incredible dust storms, they've left behind some truly massive scars on the Martian landscape. Mars is basically a cosmic museum where nothing ever gets thrown away. While Earth constantly reshapes itself through plate tectonics, earthquakes, and erosion, Mars has been preserving its ancient scars for billions of years. Think about it. Every major impact that ever happened is still there, waiting to tell its story. The biggest trophy in this collection? Hellas Basin. This massive crater stretches over 1,300 miles across and plunges 5 miles deep. That's like having a hole the size of the entire eastern United States carved into the planet. When this monster impact happened over 4 billion years ago, it probably shook the entire planet like a cosmic gong. But here's what makes Mars special. It remembers everything. Scientists use these preserved craters like a history book, counting impacts to figure out how old different regions are. More craters means older surfaces. Fewer craters? That area got resurfaced more recently. Earth loses this evidence constantly. Our restless planet erases its impact history through continental drift and weather. Mars? It's like that friend who keeps every receipt from 1985. These ancient impacts didn't just leave holes. They scattered debris, created underground fractures, and possibly even helped create the conditions where life could have thrived. Speaking of life-friendly conditions, wait until you hear about Mars' secret underground water reserves. Picture stepping up to home plate on Mars. gripping your bat and watching the pitcher wind up. The ball leaves their hand at 60 miles per hour. On Earth, that fastball would drop into the catcher's mitt in less than a second. But on Mars, you've got almost 3 times longer to react. The reduced gravity doesn't just give you more time to swing. When you make contact, that baseball would sail like a rocket. A decent pop fly on Earth becomes a home run that keeps going and going. We're talking distances that would make Babe Ruth weep with joy. A professional baseball player could theoretically hit a ball over 2,000 feet on Mars. That's nearly half a mile. The current Earth record is 575 feet, so Martian baseball would basically break every record book ever written. Tennis gets even more ridiculous. Serves would hang in the air like slow-motion replays. Basketball players could dunk from the free throw line without breaking a sweat. Golf? Forget about it. You'd need courses measured in miles, not yards. The funniest part? Running the bases would feel like bouncing on trampolines. Players would probably overshoot first base on their inaugural game, launching themselves past the bag like cartoon characters. But here's where Mars gets even stranger than sports. Picture dark streaks appearing on Martian crater walls, like someone's drawing lines with a cosmic marker. These mysterious features, called recurring slope lineae, show up seasonally and have scientists scratching their heads. Every Martian spring and summer, these dark lines materialize on steep slopes. They grow longer as the season progresses, then fade during winter months. It's like Mars has seasonal acne that comes and goes with clockwork precision. When researchers first spotted these streaks in 2011, excitement exploded. Flowing liquid water. The holy grail of Mars exploration seemed within reach. The patterns looked exactly like what you'd expect from salty water trickling down hillsides. But here's where things get complicated. Recent studies suggest these streaks might just be dry sand avalanches. Imagine the scientific equivalent of thinking you found buried treasure, only to discover it's someone's old bottle cap collection. The debate rages on because the streaks contain hydrated salts. These minerals typically form when water's present, yet no direct water detection has occurred. It's like finding a wet towel, but never seeing the shower. Some slopes show hundreds of these mysterious lines simultaneously. They're most common in Mars's southern hemisphere, appearing on crater walls steep enough to make extreme sports enthusiasts nervous. The truth behind these enigmatic features remains one of Mars's best-kept secrets. But scientists have recently uncovered something even more puzzling about the planet's interior structure. Deep beneath Mars's rusty surface lies a molten heart that's been keeping secrets for billions of years. The InSight lander changed everything we thought we knew about the red planet's core when its seismometer detected Marsquakes rippling through the planet's interior. Turns out, Mars has a partially liquid core made of iron and sulfur. That's right. While we're up here debating whether to send humans to Mars, there's a churning ocean of liquid metal spinning around down there, like some kind of planetary smoothie. The core stretches about 1,000 miles from the center, which is actually larger than scientists expected. But here's where things get really interesting. This liquid core explains why Mars lost its magnetic field billions of years ago. Earth's core keeps spinning and generating our protective magnetic bubble. Mars? Well, its core started cooling down and became less active. Without that magnetic shield, solar wind just stripped away most of the atmosphere, like a cosmic leaf blower. The sulfur content is particularly fascinating because it lowers the melting point of iron. Think of it like adding salt to ice. It stays liquid at lower temperatures. This discovery helps us understand why Mars went from a potentially habitable world to the frozen desert we see today. Speaking of ancient history, humans have been watching Mars dance across our skies for thousands of years. Humans have been staring at Mars for 4,000 years. That little red dot wandering across the night sky has captivated every civilization that bothered to look up. The ancient Babylonians were the first to keep detailed records around 2000 BCE. They called it Nergal, after their god of war and plague. Pretty fitting, considering how Mars still gives us nightmares about colonization challenges today. But here's what blows my mind. Those ancient astronomers tracked Mars with incredible precision, using nothing but their naked eyes. No telescopes, no computers, just pure human observation and mathematics. The Egyptians noticed Mars moved differently than other planets, sometimes even appearing to go backwards in the sky. They called this retrograde motion, and it puzzled stargazers for centuries. Chinese astronomers dubbed it the fire star and used its movements to predict everything from harvests to wars. Greek philosophers like Aristotle spent countless hours trying to explain why this particular planet seemed so moody compared to others. The most fascinating part? Every single culture that observed Mars associated it with conflict and change, almost like they sensed something special about our future relationship with this world. Speaking of things that seem designed to cause conflict, wait until you hear about the dust situation on Mars. If you've ever tried to clean flour off your kitchen counter, you know how stubborn fine powder can be. Well, Martian dust makes flour look cooperative. This stuff is so incredibly fine that it makes talcum powder seem chunky by comparison. Each particle measures less than 3 micrometers across. That's about 50 times smaller than the width of a human hair. But size isn't the only problem. Martian dust carries an electrostatic charge that would make a balloon at a kid's birthday party jealous. The thin atmosphere and constant friction create static electricity that turns every dust particle into a tiny magnet. It clings to absolutely everything. Solar panels, rover wheels, equipment seals, and yes, it would stick to your spacesuit like glue. The Viking landers discovered this the hard way when dust gradually covered their instruments, despite being in relatively calm areas. Here's where it gets nasty for future astronauts. This dust isn't just annoying, it's potentially dangerous. The sharp, jagged particles could damage lung tissue if inhaled. Plus, the electrostatic properties mean it penetrates the tiniest gaps in equipment. Seals that work perfectly on Earth become useless against this clingy menace. NASA engineers are already designing special airlocks and cleaning systems for future missions. But even with all that preparation, living with Martian dust will be like having an invisible, persistent house guest who never learned proper manners. Speaking of things floating in Mars's thin atmosphere, you might be surprised to learn what actually creates the beautiful clouds drifting overhead. Looking up at the Martian sky, you'd see something surprisingly familiar: wispy white clouds drifting overhead. These aren't the thick, puffy clouds we know on Earth, but delicate streaks that look almost ghostly against that butterscotch-colored sky. These clouds are made entirely of water ice, just like our cirrus clouds. But here's what's wild. They form in an atmosphere that's only 1% as thick as Earth's. That's like trying to make a snowball in a near vacuum. The fact that Mars can create clouds at all is pretty remarkable when you think about it. The clouds typically hang about 15 to 30 miles above the surface. They're so thin you could almost see through them, but rovers have captured absolutely stunning photos of these ethereal formations. Sometimes they create patterns that look like brushstrokes across the Martian horizon. What's really cool is how these clouds behave seasonally. During Martian summer, they practically vanish. But as things cool down, especially around the polar regions, these ice clouds start forming again. They follow the water cycle in ways that remind us of home, even though the conditions are completely alien. The temperature up there where clouds form, a bone-chilling minus 125 degrees Fahrenheit. But speaking of Martian ice formations, wait until you hear about the bizarre spiral pattern at the North Pole. When you look at Mars from space, the North Pole doesn't look like Earth's boring circular ice cap. Instead, it's got this incredible spiral pattern that looks like a giant cosmic cinnamon roll. And honestly, it's way cooler than anything we've got here on Earth. This spiral ice cap grows and shrinks with the seasons, but it never completely disappears. During Martian winter, it can stretch almost 700 miles across. That's like covering the entire state of Texas with a swirling ice formation. The spiral itself has these deep troughs that cut right through the ice, creating channels that look like they were carved by some cosmic artist with a serious case of OCD. But here's what makes it really weird. The spiral rotates in the same direction as the planet spins. Scientists think this happens because of the Coriolis effect, the same force that makes hurricanes spin on Earth. Except on Mars, it's creating this permanent ice sculpture that you could probably see from Jupiter with a decent telescope. The ice layers stack up like pages in a history book, with each layer telling us about Mars's climate from thousands of years ago. Some layers are pure white water ice, while others have this rusty tint from dust storms that happened ages ago. Speaking of water, Mars has been hiding liquid lakes underneath all this ice. Picture drilling through 1,500 feet of solid ice at the bottom of Mars. What would you find? Well, scientists using ground-penetrating radar just discovered something incredible hiding beneath the South Polar ice cap. Liquid water. Not frozen, not vapor. Actual flowing water. But here's where it gets wild. This isn't just a tiny puddle we're talking about. The underground lake stretches for 12 miles across. That's bigger than Manhattan. The water stays liquid, even in temperatures that would freeze your coffee instantly because it's loaded with salts. Think of it like antifreeze for planets. Why does this matter so much? Every place on Earth where we find liquid water, we find life. Every single one. From boiling hot springs to the deepest ocean trenches, life finds a way. These Martian lakes could be the perfect hiding spot for microbes that have been hanging out for millions of years. The crazy part? There might be dozens of these hidden lakes scattered across Mars. Each one could be a time capsule preserving ancient life forms, or maybe even supporting new ones right now. Getting to these lakes won't be easy, though. Imagine trying to drill through ice thicker than the Empire State Building is tall. Speaking of things that aren't easy to reach, let me tell you about how Mars plays tricks with time itself. Mars doesn't play fair when it comes to seasons. While Earth gives us roughly equal 3-month seasons, Mars laughs at that concept and delivers wildly uneven periods that would mess with your calendar planning. Spring in the northern hemisphere lasts about 7 months. 7. That's longer than most people stay committed to their New Year's resolutions. Summer stretches for 6 months, which sounds pretty great until you realize it's still freezing cold most of the time. But here's where Mars gets really weird. Fall only hangs around for about 5 months, and winter? A measly 4 months. It's like Mars has seasonal ADHD and can't decide how long each period should last. This happens because Mars follows an elliptical orbit that's much more stretched out than Earth's nearly circular path. When Mars swings closer to the Sun, it speeds up like a kid on a bike going downhill. When it's farther away, it slows down like that same kid pedaling uphill after too much Halloween candy. The southern hemisphere gets the short end of this cosmic stick. Their summer coincides with Mars being closest to the Sun, creating more intense heat. Their winter happens when Mars is farthest away, making it brutally cold. This uneven seasonal dance directly influences when those massive planet-wide dust storms decide to throw their tantrums. When ancient asteroids smashed into Mars billions of years ago, they created something absolutely stunning. Natural glass formations scattered across the planet's surface like cosmic art pieces. These aren't your typical beer bottle fragments. We're talking about impact glass forged under temperatures exceeding 2,000 degrees Fahrenheit. The collision energy was so intense, it literally melted rock and sand into beautiful, colorful glass structures. Some shine green, others glow amber, and a few even sparkle with metallic hints. But here's what makes Martian impact glass truly special. On Earth, our weather destroys this stuff pretty quickly. Rain, wind, and vegetation break it down within thousands of years. Mars? It's like a giant preservation chamber. No rain to dissolve the glass. Minimal wind erosion. These formations have been sitting there, perfectly intact, for millions of years. The really exciting part is what might be trapped inside. When that glass formed instantly during impact, it could have captured and preserved microscopic signs of ancient life. Think of it as nature's time capsule, freezing whatever was living in that moment. Every piece could hold clues about Mars' biological past. Scientists are practically drooling over these samples. But while we're admiring pretty glass formations, there's something even more dramatic happening to Mars right now. Mars is literally bleeding its atmosphere into space right now. Every single day, the red planet loses about 100 tons of its already thin atmosphere to the solar wind. That's like watching a slow-motion planetary death. The culprit? Mars lost its protective magnetic shield billions of years ago. Without that invisible force field, solar particles slam directly into the Martian atmosphere and strip away gas molecules one by one. It's cosmic bullying at its finest. NASA's MAVEN spacecraft has been watching this atmospheric escape act since 2014. The measurements are sobering. During solar storms, Mars can lose atmosphere 10 times faster than normal. Talk about bad timing for any ancient Martians who might have been around. But here's what blows my mind. Scientists calculated that if we could somehow stop this atmospheric bleeding today, it would still take millions of years to build up enough atmosphere for humans to breathe without spacesuits. Mars has been losing its air for over 3 billion years. That's a lot of catching up to do. The irony is heartbreaking. Ancient Mars probably had a thick, cozy atmosphere that could have supported life. Now it's got the atmospheric pressure of being 13 miles above Earth's surface. Speaking of ancient Mars and water, wait until you hear about the massive floods that once carved channels bigger than anything on our planet. Picture trying to drain the entire Mediterranean Sea in just a few weeks. That's basically what happened on Mars billions of years ago. except these floods made our biggest disasters look like spilled coffee. When ancient ice dams burst on Mars, they unleashed water volumes that would make Noah's flood seem like a light drizzle. We're talking about catastrophic releases that carved channels over 600 miles long and 60 miles wide. The channeled scablands in Washington state, those formed from massive floods too, but Mars said, "Hold my beer," and created features 10 times larger. The sheer power behind these megafloods is mind-boggling. Water moving at speeds of up to 60 miles per hour, carrying boulders the size of houses like they were pebbles. These weren't gradual river formations. They happened fast, geologically speaking, weeks or months at most. What's really wild is how perfectly preserved these flood channels remain after 4 billion years. On Earth, plate tectonics and erosion would have erased this evidence long ago. But Mars kept the receipts, showing us exactly where continent-sized lakes burst their banks and reshaped entire regions. The frequency of these events suggests Mars wasn't just wet once. It had repeated cycles of massive water storage and catastrophic release. Speaking of cycles, there's something equally fascinating about how Mars developed the smoothest surfaces in our entire solar system. Here's something that'll blow your mind about Mars' resource utilization. That rusty red dirt covering the planet? It's basically a rocket fuel factory waiting to happen. The Martian atmosphere is 95% carbon dioxide, which sounds useless until you realize what that means. With the right equipment, you can split CO2 into carbon monoxide and oxygen. Add some hydrogen from underground ice, and boom, you've got methane and oxygen. That's rocket fuel, people. NASA's already testing this with MOXIE, a toaster-sized device on the Perseverance rover. It's literally making oxygen from thin air. Well, thin Martian air. The results are promising enough that future missions are banking on this technology. But here's where it gets really clever. The iron oxide that makes Mars red, that's another gold mine. Heat it up with hydrogen, and you get water vapor plus pure iron. The water can be split into hydrogen and oxygen for fuel. The iron, perfect for building habitats and tools. Even the soil itself contains sulfur compounds that could become rocket propellant with some chemical wizardry. It's like Mars is practically begging us to use its resources to leave again. This isn't just convenient, it's survival. Hauling fuel from Earth to Mars costs millions per pound. Making it locally, game changer. Speaking of changes, wait until you hear about the smoothest terrain in our entire solar system. When you think of smooth surfaces, you probably picture a freshly paved highway or a polished marble floor. Well, Mars has something that makes both look bumpy by comparison. Amazonas planitia, located in the northern lowlands, ranks as the smoothest place in our entire solar system. How smooth are we talking? Over an area roughly the size of Australia, the elevation barely changes by more than a few hundred feet. That's like having a football field, where the height difference between the goalposts is less than the thickness of a penny. Engineers dream about surfaces this flat. The formation story reads like a geological recipe for perfection. Ancient volcanic eruptions laid down layer after layer of incredibly fluid lava, flowing like cosmic pancake batter across hundreds of thousands of square miles. Then massive floods, possibly from underground aquifers bursting through the crust, smoothed everything even further. Mission planners absolutely love this region. Landing a spacecraft here is like parking in an empty lot compared to threading the needle elsewhere on Mars. No surprise that multiple successful missions have touched down in these plains. But here's what really gets interesting about this smooth paradise. The very processes that created this flawless surface also reveal something disturbing about Mars's violent past. When the planet was literally reshaping itself through catastrophic events, Mars once had a magnetic field just like Earth's. Then it vanished. Nobody knows exactly why, and that mystery keeps scientists awake at night. Picture our planet without its magnetic shield. Solar radiation would strip away our atmosphere. Oceans would boil into space, and life as we know it would cease to exist. That's exactly what happened to Mars about 4 billion years ago. The evidence is written in stone, literally. Ancient Martian rocks contain tiny magnetic minerals that point in random directions, like frozen compass needles, from a time when Mars had a global magnetic field. These rocks are geological time capsules, proving that early Mars was magnetically active and potentially habitable. But here's where things get weird. The magnetic field didn't fade gradually like a dying battery. It switched off relatively quickly in geological terms. Within a few 100 million years, Mars went from having a protective magnetic bubble to being defenseless against cosmic radiation. Several theories attempt to explain this planetary catastrophe. Maybe the Martian core cooled too quickly to maintain the dynamo effect that generates magnetic fields. Perhaps a massive asteroid impact disrupted the core's circulation, or the planet's smaller size simply couldn't sustain the internal heat needed for magnetic field generation. Without this protection, Mars lost most of its atmosphere to space. But the planet's dramatic climate changes didn't stop there. Picture yourself soaking in a hot spring on a snowy mountain. Steam rises, your muscles relax, and you feel completely rejuvenated. Well, Mars had its own version of hot springs billions of years ago, and they're still perfectly preserved in rock today. The Spirit rover stumbled upon something extraordinary in 2006. Silica deposits scattered across the Martian landscape told an incredible story. These weren't just random rocks. They were fossilized evidence of ancient hydrothermal activity. Hot water once bubbled up from Mars's interior, creating mineral-rich springs that could have been paradise for early life. But here's what blows my mind. These silica formations are nearly identical to deposits found around hot springs in Yellowstone National Park. The same chemical processes that create those stunning terraces on Earth happened on Mars when our planetary neighbor was young and wet. Talk about cosmic déjà vu. The preservation is absolutely remarkable. Without wind, rain, or tectonic activity to destroy them, these ancient spa locations have remained frozen in time for over 3 billion years. Scientists can study them like geological time capsules, learning exactly what conditions existed when Mars might have been habitable. And the weird part? Some of these deposits show signs that the hot springs operated for thousands, maybe millions of years. That's plenty of time for life to potentially establish itself. Makes you wonder what other surprises Mars has hidden beneath its dusty surface. Standing on Mars would instantly make you feel like a superhero. Well, sort of. Your weight would drop by a whopping 62%. That means if you weigh 150 pounds on Earth, you'd only weigh 57 pounds on the red planet. But here's the catch. This isn't exactly the superpower you might think it is. Sure, jumping would feel amazing at first. You could probably leap 3 times higher than on Earth without breaking a sweat. Walking would feel bouncy and fun, like you're constantly on a trampoline. However, Your muscles and bones wouldn't be throwing a party about this change. They're designed for Earth's gravity, and they need that constant resistance to stay strong. Without it, astronauts start losing bone density and muscle mass pretty quickly. It's like the ultimate use it or lose it situation. Future Mars colonists would need to exercise for hours every day just to keep their bodies functioning properly. Think of it as mandatory gym time, except the consequences of skipping are way worse than just feeling guilty. The psychological effects are fascinating too. Many astronauts report feeling oddly disconnected when gravity changes dramatically. Your brain expects things to fall at certain speeds, and Mars would mess with those expectations constantly. Speaking of things that mess with expectations, wait until you hear about the extreme temperature swings you'd face there. Hidden beneath Mars' rusty surface lies a frozen treasure that could change everything about human survival on the red planet. We're talking about subsurface ice scattered throughout virtually the entire planet. This isn't just a little frost here and there. Massive sheets of ice exist just beneath the Martian soil, sometimes only a few feet down. Think of it as nature's own water storage system, perfectly preserved in the planet's freezer-like conditions for millions of years. The cool part? Some of these ice deposits are so close to the surface that future astronauts could literally dig them up with a shovel. Well, maybe a really good shovel and some elbow grease, but you get the idea. Scientists have mapped these ice reserves using ground-penetrating radar, and the results are mind-blowing. There's enough frozen water spread across Mars to supply human colonies for centuries. The ice forms what researchers call permafrost, similar to what we find in Alaska or Siberia, except way more extensive. Here's where things get practical. This underground ice could provide drinking water, oxygen for breathing, and even hydrogen for rocket fuel. It's like Mars left us a welcome gift buried in its backyard. But accessing this frozen gold mine presents some interesting challenges that make Earth's most extreme mining operations look like a walk in the park. The temperature swings on Mars would make Earth's worst weather days feel like a gentle breeze. We're talking about daily temperature differences that can reach 170 degrees Fahrenheit. That's like going from a pleasant spring morning to the inside of a freezer in just a few hours. Why does this happen? Mars has practically no atmosphere to trap heat. Think of Earth's atmosphere like a cozy blanket that keeps us warm at night. Mars? It's basically sleeping naked in space. During the Martian day, temperatures might climb to an almost comfortable 70 degrees Fahrenheit at the equator. Sounds nice, right? Well, don't pack your beach towel just yet. When night falls, those same spots plummet to minus 100 degrees Fahrenheit. Your morning coffee would literally shatter if you left it outside overnight. This creates serious headaches for any equipment we send there. Metal expands and contracts so dramatically that bolts can snap and circuits can crack. Even our toughest rovers have to be built like mechanical yoga masters, flexible enough to handle this daily torture. For future astronauts, this means habitat design becomes absolutely critical. One small heating failure during a Martian night could turn deadly within minutes. But here's something even more mind-bending about Mars. The planet actually has ancient shorelines that tell an incredible story. Ever wonder what happened to all that ancient water we keep talking about? Well, Mars still carries the scars of its watery past like geological tattoos. Scientists have discovered multiple ancient coastlines etched into the Martian surface, marking where vast oceans once lapped against alien shores billions of years ago. The most famous of these phantom beaches is called Arabia Terra. It stretches for thousands of miles across the northern hemisphere, sitting about 2 miles above the current surface level. That's right, Mars once had oceanfront property that would make Malibu jealous. But here's where it gets wild. There aren't just one or two coastlines. Mars has at least 3 distinct shoreline levels, suggesting the planet experienced multiple ocean periods. Each one tells a different chapter in Mars' climate story. The highest shoreline indicates an ocean that covered nearly 40% of the planet's surface. That's bigger than our Atlantic Ocean. These ancient beaches contain specific rock formations that only form where water meets land. Wave-carved cliffs, sediment deposits, and even what look like ancient harbor formations. The evidence is so clear that researchers can actually map out where the best beaches would have been. The really mind-bending part: some of these coastlines show signs of freezing and thawing cycles, hinting at seasonal changes that lasted millions of years. But why did all this water vanish? That mystery leads us to one of Mars' most dramatic atmospheric discoveries. These Martian dust devils aren't your typical backyard whirlwinds. We're talking about towering atmospheric monsters that can stretch 12 miles into the sky. That's twice as high as commercial airliners fly on Earth. The thin Martian atmosphere actually helps these spinning columns of dust grow to incredible heights. With less air resistance and lower gravity, dust devils can maintain their structure much longer than on Earth. Some last for hours, wandering across the Martian plains like lost giants. But here's the funny thing. These terrifying-looking phenomena are actually Mars rovers' best friends. The spinning winds act like natural janitors, cleaning dust off solar panels that power our robotic explorers. Without these helpful dust devils, missions like Spirit and Opportunity would have died much sooner from dust-covered panels. The formation process is surprisingly similar to Earth's dust devils, just supersized. Solar heating creates temperature differences that generate updrafts, and the planet's rotation adds the signature twist. But on Mars, these can grow into continent-crossing weather events. Watching time-lapse footage of these giants is mesmerizing. They move across the landscape like slow-motion tornadoes, leaving dark trails in their wake as they sweep away the rusty surface dust. Then there's something even more impressive hidden beneath Mars's surface. Ancient rock formations that tell stories spanning billions of years. Mars is basically a giant history book, written in stone, and every layer tells a story that would make any geologist weep with joy. These aren't just random rock piles scattered around the planet. We're talking about perfectly preserved sedimentary deposits that chronicle millions of years of Martian climate changes. The layered formations work exactly like tree rings, except instead of counting years, we're reading entire geological epochs. When Mars had flowing water, it left behind specific mineral signatures. When the planet dried up, that created completely different rock types. Each layer captures a snapshot of what Mars was like when it formed. Curiosity rover has been drilling into these formations for years, and the results are mind-blowing. Some layers show evidence of ancient lake beds that existed for thousands of years. Others reveal periods when Mars was bone dry and getting sandblasted by massive dust storms. The planet basically went through multiple personality changes, switching between wet and dry periods like a cosmic mood ring. Scientists can determine not just whether water existed, but how much, how long it lasted, and what the temperature conditions were like. Some rock layers even contain organic molecules that have been preserved for billions of years. But here's what gets really interesting about Mars exploration. We've barely scratched the surface of what this planet might be hiding beneath our feet. The Martian surface pressure sits at just 0.6% compared to Earth's atmosphere. That's like standing 22 miles above our planet, where commercial jets can't even fly. Your blood would literally boil without a pressure suit. Not from heat, but because liquids need pressure to stay liquid. It's the same reason astronauts wear those bulky suits in space. Think about opening a soda bottle that's been shaken. The carbon dioxide explodes out because pressure drops suddenly. That's essentially what would happen to the dissolved gases in your bloodstream on Mars. Ouch. But here's what's really wild about this thin atmosphere. It creates some bizarre physics. Water can't exist as a liquid on most of the Martian surface. Pour a glass of water outside your Mars habitat, and it would either freeze solid or boil away instantly, depending on the temperature. The low pressure also means parachutes barely work for landing spacecraft. NASA has to use rockets, airbags, or that crazy sky crane system because there's simply not enough air to slow things down properly. Walking around would feel strange too. Your ears would pop constantly as your body tries to equalize pressure that isn't there. Speaking of strange sensations, wait until you hear how the lack of atmospheric protection affects something even more dangerous than pressure. Radiation levels that would literally cook you from the inside. While we're busy figuring out how to grow potatoes on Mars, there's something else buried in that rusty soil. Treasure. Actual treasure. Mars sits on mineral deposits worth more money than every economy on Earth combined. We're talking trillions upon trillions of dollars. The kind of numbers that make Jeff Bezos look like he's checking couch cushions for spare change. The red planet is loaded with platinum, gold, and rare Earth elements that make our smartphones work. These aren't just scattered around randomly either. They're concentrated in massive deposits that formed when Mars was geologically active billions of years ago. But here's where it gets ridiculous. One asteroid mining company calculated that a single metallic asteroid near Mars contains more platinum than has ever been mined on Earth. Ever. The entire human history of platinum mining wouldn't even scratch the surface of what's floating around up there. Of course, there's a tiny problem with this cosmic gold rush. Getting those materials back to Earth would cost more than they're worth. At least with today's technology. It's like finding a winning lottery ticket at the bottom of the ocean while wearing concrete shoes. The real value might be for Mars colonists themselves. Why ship materials from Earth when you're literally standing on a planetary jewelry store? Speaking of standing on things, Mars might seem like the perfect escape from Earth's problems. But the red planet is actively trying to kill you with invisible radiation. Every single day, cosmic rays and solar particles slam into the Martian surface with zero mercy. Without Earth's protective magnetic field and thick atmosphere, Mars is basically a radiation shooting gallery. Astronauts would absorb about 100 times more radiation than people on Earth. That's like getting a chest X-ray every few days, except it never stops. The numbers are genuinely terrifying. During an 18-month mission to Mars, astronauts would receive radiation doses that significantly increase their cancer risk. We're talking about a 5% jump in lifetime cancer probability. That might not sound huge, but for context, that's considered unacceptable by current space safety standards. Here's the brutal reality. Long-term Mars colonists would face even worse exposure. The the constant bombardment would damage DNA, increase cancer rates, and possibly cause cataracts and central nervous system problems. Your cells would literally be under attack 24/7. But engineers aren't giving up. They're designing underground habitats, radiation-resistant materials, and even artificial magnetic shields. Some propose living in lava tubes or covering habitats with thick Martian soil. While radiation poses serious challenges, scientists have discovered something even more puzzling about Mars's atmosphere that appears and vanishes like a ghost. Mars has this weird habit of burping methane into space, then making it completely disappear like some cosmic magic trick. One day, satellites detect these mysterious methane plumes floating around the planet, and the next day, gone without a trace. The disappearing act happens so fast, it's honestly baffling. Methane should stick around for hundreds of years in Mars' thin atmosphere, but somehow it vanishes in just a few hours or days. That's like expecting your leftover pizza to last a week and finding it gone before lunch. What makes this even more intriguing is where the methane might be coming from. On Earth, 90% of atmospheric methane comes from living organisms. Cows, bacteria, swamps, all pumping out this gas as they go about their biological business. The other 10% comes from geological processes like volcanic activity. But Mars isn't exactly known for its thriving cow population. So either there are microbes hiding somewhere beneath the surface, happily producing methane as they've done for millions of years, or Mars has some seriously active geology we haven't discovered yet. The timing adds another layer of mystery. These methane burps seem to follow seasonal patterns, appearing more frequently during Martian summer. Coincidence? Probably not. Speaking of Mars defying expectations, wait until you hear how the planet literally messes with your vision in ways you'd never expect. When you step outside on Mars and look toward the horizon, something feels immediately wrong. The edge of the world appears much closer than it should. It's like standing on a really tall hill, except you're not. This isn't some optical illusion playing tricks on your eyes. Mars is genuinely smaller than Earth, way smaller. While our planet has a radius of about 4,000 miles, Mars clocks in at just over 2,000 miles. That's roughly half the size, which means the horizon literally is closer. But here's where your brain starts messing with you. On Earth, the horizon sits about 3 miles away when you're standing at sea level. On Mars, you're looking at just 2 miles before the planet curves away from sight. Doesn't sound like much of a difference, right? Wrong. Your brain evolved on Earth. It expects horizons to behave a certain way. When everything looks closer than it should, it creates this weird claustrophobic feeling. Like you're trapped inside a snow globe instead of standing on an entire planet. Early Mars colonists might experience genuine psychological stress from this. The sky feels lower, the world feels smaller, and escape feels impossible. Even taking photos becomes tricky, since everything appears more compressed than expected. Speaking of water and vast distances, Mars once had rivers that would make Earth's Amazon look like a creek. When we think about massive river systems, the Amazon comes to mind immediately. But here's something that'll blow your mind. Mars once had riverbeds that made the Amazon look like a garden hose. These ancient Martian waterways weren't just bigger. They were absolutely colossal. Some of these prehistoric channels stretched over 2,000 miles long and carved valleys hundreds of miles wide. The sheer volume of water that once flowed through these systems is mind-boggling. Scientists estimate that at peak flow, some Martian rivers carried more water in a single day than the Amazon does in an entire year. That's roughly 50 million gallons per second, thundering across the red planet's surface. Makes sense, right? But here's where it gets really wild. These weren't gentle, meandering streams taking millions of years to carve their paths. Evidence suggests many formed during catastrophic flooding events that reshaped entire continents in just weeks or months. The most impressive example is Case Valles, a channel system so massive it could swallow the entire state of Texas. The water that carved this beast was moving at highway speeds, ripping house-sized boulders from bedrock like they were pebbles. What's fascinating is how these ancient flows left behind detailed records of Mars' watery past. But the real mystery isn't just how much water flowed, it's where all that water disappeared to so completely. Picture this: dust storms on Mars that crackle with electrical energy, but not a single drop of rain falls. Mars throws lightning parties in the driest conditions imaginable. When Martian dust storms rage across the planet, they generate massive amounts of static electricity. Think about rubbing a balloon on your hair, then multiply that by several billion. The tiny dust particles slam into each other at incredible speeds, creating electrical charges that build up until, zap, lightning streaks through the butterscotch sky. But here's where it gets wild. On Earth, we're used to lightning coming with thunderstorms and rain. Mars flips that script completely. These electrical light shows happen in bone-dry conditions, where water vapor is practically non-existent. The dust particles are so fine, they're like microscopic sandpaper floating in the air. When billions of these particles collide during planet-wide storms, they create electrical fields powerful enough to fry electronics. NASA has actually detected these electrical discharges from orbiting spacecraft, watching Mars put on its own version of a fireworks display. What makes this even more incredible? The lightning happens without the thunder we'd expect. Mars's thin atmosphere means sound travels differently, so these cosmic light shows are eerily silent. But electrical storms aren't the only thing that makes Mars spin in mysterious ways. Ever notice how Earth's days get slightly longer or shorter throughout the year? Well, Mars pulls the same trick, but for a completely different reason. That'll make you appreciate planetary physics in a whole new way. Mars literally changes how fast it spins based on the seasons. We're talking about actual measurable differences in the length of a Martian day. During winter, a Martian day becomes about 1 millisecond shorter. Summer? It stretches out by the same amount. The culprit isn't some mysterious space force. It's the atmosphere itself, playing cosmic tricks. When winter hits Mars, massive amounts of carbon dioxide freeze out of the air and pile up at the poles as dry ice. This redistribution of atmospheric mass affects the planet's moment of inertia, kind of like how figure skaters spin faster when they pull their arms in. But here's where it gets really wild. The effect is so precise that NASA has to account for these tiny timing changes when planning rover operations and orbital maneuvers. Mission controllers literally have to update their clocks based on Martian weather patterns. Earth does something similar, but our changes come from ocean currents and wind patterns moving water around. Mars uses its entire atmosphere as a planetary speed controller. Talk about efficient engineering. And speaking of Mars engineering marvels, wait until you hear about the toxic dust problem that makes every breath potentially deadly. Remember those beautiful butterscotch landscapes we talked about? Well, there's a deadly secret hiding in that picturesque Martian dust. Every grain covering the planet's surface contains chemicals that could seriously harm any human brave enough to step foot there. The culprit is something called perchlorates. These toxic compounds make up about 0.5% of Martian soil, which might sound tiny, but it's actually a massive problem. To put this in perspective, that's like having poison sprinkled throughout every handful of dirt on the entire planet. What makes perchlorates so dangerous? They attack your thyroid gland, which controls your metabolism and basically keeps your body running smoothly. Breathe in enough of this dust, and your thyroid starts shutting down. But here's the really scary part. This stuff gets everywhere. Mars has frequent dust storms, and that fine powder becomes airborne constantly. Even worse, perchlorates can cause serious lung damage if inhaled. The dust particles are incredibly fine, smaller than talcum powder, so they penetrate deep into your respiratory system. Astronauts would need serious decontamination procedures just to enter their habitats safely. Interestingly, though, these same toxic chemicals might actually help us detect life. Certain Earth microbes can eat perchlorates and thrive on them. But speaking of Martian water, there's something fascinating about how H2O behaves on the red planet's surface. Picture yourself standing on the edge of an ancient lake that once sparkled under butterscotch Martian skies. Well, that dream isn't as crazy as it sounds. Mars actually has deltas, those fan-shaped formations where rivers dump sediment into standing water, proving that substantial lakes existed for thousands, maybe millions of years. The most famous example sits right in Jezero Crater, where NASA's Perseverance rover is currently digging around like an enthusiastic geologist. This delta is absolutely massive, stretching over 8 miles wide. The sediment layers tell an incredible story of water flowing consistently enough to build these intricate formations. But here's what blows my mind. These aren't flash flood deposits. Deltas require sustained water flow over long periods. We're talking about rivers that flowed reliably into stable lakes, creating environments that could have supported life for geological timescales. The rock layers show multiple episodes of delta building, meaning these lakes filled up, dried out, then filled again repeatedly. The engineering precision of these formations rivals anything on Earth. Scientists can actually read the water levels like pages in a book, tracking how deep these ancient lakes were and how long they lasted. Some estimates suggest certain Martian lakes persisted for millions of years, plenty of time for life to establish itself. Speaking of time, Mars holds even stranger secrets about how long things can last in its environment. Picture trying to read a book on Mars and squinting because everything looks dimmer than expected. Well, that's exactly what future astronauts will experience. Martian sunlight delivers only half the brightness we enjoy on Earth. This happens because Mars sits about 50% farther from the sun than our planet does. Distance matters enormously when it comes to solar energy. Think of it like moving twice as far from a campfire. Suddenly, you're not feeling much warmth anymore. For solar panels, this creates a massive headache. Engineers designing Mars missions have to build panels twice as large or twice as efficient just to generate the same power. The math gets ugly fast when you're trying to keep a habitat running on weak sunlight. But here's what's really wild. Your eyes would actually adapt pretty well. Humans are surprisingly good at adjusting to different light levels. After a few weeks on Mars, that dimmer environment would start feeling normal. You'd probably forget how bright Earth's sun actually blazes until you returned home and got temporarily blinded by our intense daylight. The bigger challenge: growing food becomes incredibly tricky when plants receive half their expected solar energy. Martian farmers will need some serious artificial lighting setups. Speaking of lighting challenges, wait until you discover the massive underground cave systems where future colonists might actually want to live. Deep beneath Mars's surface lies a network of caves so massive they make Earth's cave systems look like ant tunnels. We're talking about lava tubes that stretch for hundreds of miles underground, created when ancient volcanic activity left behind these incredible natural tunnels. But here's what blows my mind about these Martian caves. They're absolutely perfect shelters for future astronauts. While the surface gets bombarded with deadly radiation and experiences those brutal temperature swings we talked about earlier, these underground chambers maintain relatively stable conditions. Think of them as nature's own space stations, already built and waiting for us. The largest of these lava tubes could easily fit entire cities inside them. Some are wide enough that you could drive a football stadium through them sideways. And unlike Earth's caves that often collapse or fill with water, Mars's low gravity and lack of tectonic activity means these structures have remained intact for millions of years. What makes these caves even more appealing is their protection factor. They shield against cosmic radiation that would fry unprotected humans on the surface. They're also naturally insulated, which means less energy needed for heating and cooling future habitats. The challenge? Getting robots down there to explore them properly is like trying to navigate a maze blindfolded. But speaking of Mars's massive scale, wait until you hear about just how much territory there is to explore up on the surface. When you look at Mars from space, it seems pretty small compared to Earth. Well, here's something that'll blow your mind. Mars has a surface area equal to all of Earth's continents combined. Let me break this down for you. Earth is bigger overall, sure, but 71% of our planet is covered in oceans. Mars, 0 oceans. That means every single square mile on Mars is dry land waiting to be explored. We're talking about 55 million square miles of Martian real estate. That's like having North America, South America, Europe, Asia, Africa, Australia, and Antarctica, all rolled into one massive playground. Makes sense, right? But here's where it gets wild. We've barely scratched the surface of exploring this place. All our rovers combined have covered less area than a typical city neighborhood. It's like trying to understand Earth by only looking at your backyard. Think about what this means for future colonists. There's room for countless settlements, mining operations, research stations, and maybe even Martian national parks. The northern plains alone could fit the entire United States with room to spare. And unlike Earth, where prime real estate gets snatched up quickly, Mars has prime locations everywhere. Crater rims with stunning views, ancient riverbeds rich in minerals, polar regions with endless ice supplies. Speaking of water, there's something fascinating about how Martian landscapes still show signs of flowing activity. Mars has these weird streaky features called gullies that scientists absolutely cannot agree on. They look like someone took a garden hose and carved channels down crater walls and steep slopes. The crazy part? Some of these might actually be flowing today. When Mars Global Surveyor first spotted these gullies in 2000, everyone got excited, thinking they'd found proof of liquid water. These dark streaks appear seasonally, usually during Mars' warmer months, then fade away, It's like the planet is playing hide and seek with us. But here's where things get messy. Half the researchers swear it's briny water, salty enough to stay liquid in Mars's freezing temperatures. The other half insist it's just dry sand and dust tumbling down slopes like tiny avalanches. Both sides have compelling evidence, which makes this one of Mars' most frustrating mysteries. The really wild thing is that we're watching these gullies change in real time. Satellite images show new ones appearing between photo sessions. Something is definitely happening down there, whether it's wet or dry. Some gullies stretch for hundreds of feet, carving surprisingly deep channels for something that might just be shifting sand. The debate rages on because proving liquid water would be huge for finding life. Speaking of water mysteries, wait until you hear what Mars soil actually contains. Who would have thought that the rusty, seemingly barren soil of Mars could actually nurture life? The reddish dirt that makes Mars look so alien from space contains nearly every essential nutrient that plants need to survive. It's got nitrogen, phosphorus, potassium, and dozens of trace minerals that would make any Earth gardener jealous. But here's where it gets tricky. Remember those toxic perch lorets we mentioned earlier? Yeah, they're still there, turning Martian soil into basically poisoned plant food. It's like having a gourmet meal laced with arsenic. The good news? Those chemicals can be washed out or neutralized with some clever engineering. NASA has already tested this concept. They grew potatoes in simulated Martian soil after treating it to remove the nasty stuff. The results were surprisingly promising. The plants didn't just survive, they actually thrived. Some varieties produced yields comparable to Earth-grown crops. The soil's fine, powdery texture means it holds water well once you add some. Mix in a bit of compost from recycled organic waste, and you've got yourself a decent growing medium. Future Mars colonists could potentially grow tomatoes, lettuce, and even wheat in pressurized greenhouses. Of course, there's still the challenge of creating breathable atmospheres for both plants and humans. Speaking of atmosphere, did you know that Mars experiences something truly spectacular twice every 11 hours? Picture this. You're relaxing on Mars after a long day of terraforming, and you look up to see Phobos rising in the butterscotch sky. Wait 11 hours, and you'll see it rise again. That's right. Mars gives you moonrise and moonset every 11 hours. Phobos races around Mars so fast, it's basically the overachiever of moons. While Earth's moon takes about 29 and a half days to complete one orbit, Phobos does it in just 7.5 hours. This little potato-shaped moon is so speedy that it actually rises in the west and sets in the east, backwards from what we're used to on Earth. For future Mars colonists, this creates some pretty wild skywatching opportunities. You could literally see Phobos rise, grab a meal, take a nap, and watch it rise again before bedtime. It would be like having a built-in 11-hour timer in the sky. The rapid orbit also means Martian sailors could use Phobos for navigation, tracking time, or just entertainment during those long Martian nights. Imagine trying to write romantic poetry about a moon that zips across the sky 3 times a day. But here's what's really fascinating about Mars's relationship with its tiny moons. Their gravitational effects create something completely unexpected. Mars literally breathes throughout the year, and it's one of the most dramatic atmospheric changes you'll find anywhere in our solar system. The planet's atmosphere actually swells and shrinks by 25% as the seasons change. That's like Earth's atmosphere suddenly becoming a quarter thicker every winter. The reason behind this cosmic breathing is surprisingly simple. Mars has those massive polar ice caps we talked about earlier, but here's what makes them special. They're not just water ice. The southern ice cap contains huge amounts of frozen carbon dioxide, basically dry ice on a planetary scale. When winter hits the southern hemisphere, temperatures plummet so low that carbon dioxide literally freezes out of the atmosphere and onto the ice cap. We're talking about billions of tons of gas becoming solid. The atmosphere gets thinner. Pressure drops across the entire planet. Then summer arrives, and all that frozen carbon dioxide sublimates back into gas, making the atmosphere thicker again. This creates some wild weather patterns. Dust storms often kick up during these pressure changes, and the winds shift dramatically. Any future Mars colonists will need equipment that can handle these constant pressure variations. Imagine your barometer swinging wildly every few months. But here's something even stranger about Mars weather. The planet actually experiences precipitation that would seem impossible. The Curiosity rover has been drilling into Martian rocks and finding something incredible. Organic molecules. Not just any rocks either. We're talking about ancient mudstone that's been sitting there for over 3 billion years, perfectly preserved like nature's own time capsule. Now hold on. Before you start planning your welcome party for little green men, organic molecules don't automatically mean life. They're basically carbon-based compounds that could come from biological processes or just plain old chemistry. But here's what makes this discovery absolutely mind-blowing. These molecules survive for billions of years on a planet that's basically a radiation-soaked desert. The mudstone acted like the universe's best filing cabinet. Clay minerals have this amazing ability to trap and protect organic compounds from Mars's harsh environment. Think of it like finding a perfectly preserved newspaper from 3 billion years ago, except instead of sports scores, it might contain clues about ancient Martian life. The rover found different types of organic molecules, including some that release sulfur compounds when heated. That's particularly exciting because sulfur-based chemistry is often associated with life processes. What's even crazier? These discoveries suggest that early Mars had all the right ingredients for life to potentially develop. But Mars had another trick up its sleeve that scientists are still trying to understand. Imagine trying to enjoy a nice glass of water on Mars. Well, you'd be out of luck. Any liquid water you brought to the Martian surface would instantly start boiling like a mad science experiment gone wrong. And no, it wouldn't be because of heat. The culprit? Mars has ridiculously low atmospheric pressure. We're talking about pressure that's less than 1% of what we have on Earth. That's like being 22 miles above our planet's surface, where the air is so thin that your blood would literally boil. Water needs a certain amount of atmospheric pressure to stay liquid. Without it, those H2O molecules get excited and jump straight into gas form faster than you can say dehydration. Even if the temperature was perfect for a refreshing drink, physics would ruin your day. But here's where Mars gets sneaky. While surface water throws its molecular tantrum, underground is a completely different story. Scientists have found evidence of liquid water hiding beneath the surface, especially near the polar regions. These underground pools stay liquid because they're salty as heck and protected from the surface pressure nightmare. The salt acts like nature's antifreeze, keeping the water from freezing solid even in Mars's brutal cold. Plus, being underground means more pressure and protection from the thin atmosphere above. Speaking of Mars's atmospheric quirks, wait until you hear about the planet's bizarre wind patterns. Looking up at Mars through a telescope, you might think the planet's poles are pretty standard. Two white caps sitting at opposite ends like Earth's. Well, Mars decided to get a little artistic with its northern ice cap. The North Polar region displays something you won't find anywhere else in our solar system. Hexagonal patterns carved directly into the ice. These aren't random cracks or simple geometric shapes. They're perfectly formed six-sided patterns that look like nature decided to play architect. What creates these bizarre formations? The answer lies in Mars's seasonal dance with carbon dioxide. During winter, the atmosphere gets so cold that carbon dioxide literally freezes out of the air and lands on the ice cap. But here's where things get weird. When spring arrives, this frozen carbon dioxide doesn't melt gradually like you'd expect. Instead, it sublimates directly from solid to gas, creating pressure underneath the ice. This pressure finds weak spots and carves channels in perfectly geometric patterns. The hexagons form because of how the sublimation process spreads. Each point of pressure release affects the areas around it in equal directions, naturally creating six-sided shapes. It's like Mars is showing off its geometry skills. These formations can stretch for miles across the polar landscape, creating a honeycomb pattern visible from orbit. Astronauts visiting Mars will witness landscapes that seem more alien than anything we've imagined. But geometric ice patterns aren't Mars's only artistic achievement. For billions of years, Mars has been getting a cosmic makeover courtesy of relentless winds. While Earth has water, ice, and tectonic plates constantly reshaping its surface, Mars relies almost entirely on wind to sculpt its landscape. And boy, has it done a thorough job. The Martian winds have carved towering rock formations that look like abstract art pieces. These aren't gentle breezes we're talking about. They're powerful enough to move sand dunes the size of city blocks. Some of these dunes migrate several feet every Martian year, which is pretty impressive when you consider the thin atmosphere. But here's where it gets wild. The wind has created features that seem almost impossible. There are rocks balanced precariously on thin pedestals, carved so precisely they look like alien sculptures. Wind erosion has hollowed out caves, polished surfaces to mirror-like smoothness, and created ripple patterns in the sand that stretch for miles. The most mind-blowing part? These wind patterns tell stories. Scientists can read the direction and strength of ancient winds by studying rock formations. It's like Mars kept a diary written in stone and sand. What makes this even more fascinating is that despite having such a thin atmosphere, Martian winds can still move particles with incredible force. Speaking of incredible forces, wait until you hear about the ancient volcanic activity that literally built mountains. Mars isn't just hiding water underground. It's preserving some of the most incredible evidence of ancient life-supporting environments you could imagine. We're talking about hot spring deposits so rich in silica that they make Yellowstone look like a puddle. When rovers started analyzing certain rock formations, they found something extraordinary. Layers upon layers of silica deposits formed exactly the way hot springs create them on Earth. These weren't just any hot springs either. They were massive hydrothermal systems that bubbled and steamed for potentially millions of years. Why does this matter so much? Hot springs on Earth are basically life factories. They're where some scientists think life itself might have started. The warm water, the mineral-rich environment, the chemical reactions happening 24/7. It's like nature's perfect laboratory for cooking up living organisms. The silica acts like a time capsule. On Earth, hot spring silica preserves everything from bacteria to plant material with incredible detail. If Mars had microbes hanging around these ancient hot springs, there's a real chance they're still there, perfectly preserved in the rock. What makes this even more mind-blowing is the timeline. These deposits formed when Mars was transitioning from its wet period to the dry wasteland we see today. But Mars has been keeping another massive secret about how wind has been the planet's ultimate sculptor for billions of years. Here's something that would definitely mess with your head on Mars. Your cardiovascular system would basically need a complete reboot. We're talking about blood flow changes so dramatic that doctors are already losing sleep over it. Your heart, which has been faithfully pumping blood against Earth's gravity for your entire life, suddenly finds itself in a gravity field that's only 38% as strong. Sounds relaxing, right? Well, your circulatory system doesn't think so. Blood that normally pools in your legs thanks to good old Earth gravity, it starts floating upward like a lazy river. Your face puffs up. Your legs shrink down. You'd look like someone squeezed you from the bottom and inflated your head like a balloon. But here's where things get seriously weird. Your heart, being the overachiever it is, keeps pumping as if you're still on Earth. Except now, there's less resistance. Blood pressure spikes in your upper body, while your legs basically become blood deserts. Astronauts on the International Space Station already deal with this in zero gravity, but Mars presents a unique middle ground that nobody's quite figured out yet. Your body would be constantly confused, not weightless enough to fully adapt, not heavy enough to work normally. The exercise requirements alone would be insane. Speaking of insane, wait until you hear about Mars's mysterious dark streaks that appear and disappear like planetary graffiti. The slopes of Mars are home to one of the planet's most puzzling mysteries. Dark streaks appear every Martian summer, flowing down crater walls and canyon sides like cosmic tears. These mysterious features stretch for hundreds of feet, appearing almost overnight when temperatures rise above negative 160 degrees Fahrenheit. What makes these streaks so intriguing? They vanish completely during winter, only to reappear in exactly the same locations the following year. It's like Mars has seasonal tattoos that come and go with clockwork precision. The leading theory suggests these dark lines form when underground briny water seeps to the surface. Salt in the water lowers its freezing point, allowing it to remain liquid in Mars's frigid conditions. When this salty cocktail reaches the surface, it darkens the soil and creates these enigmatic streaks. But here's where things get controversial. Some researchers argue it's not water at all. They believe dry sand and dust simply slide down these slopes, creating the same visual effect. The debate has raged for over a decade, with evidence supporting both sides. These recurring slope lineae, as scientists call them, could represent the closest thing to active flowing water on modern Mars. If they're truly water-based, they might harbor the planet's first confirmed signs of current life. Speaking of current mysteries, Mars holds even stranger secrets about its atmospheric chemistry that change with the seasons. Hidden beneath Mars's rusty surface lies enough frozen water to completely flood the entire planet. We're talking about a layer roughly 14 feet deep, covering every square inch of the red planet. That's more water than some countries see in a decade. Most people think Mars is bone dry, but they're dead wrong. The planet is basically a giant ice cube wrapped in dirt and rocks. Scientists discovered this massive water reserve using ground-penetrating radar and neutron detectors that can sniff out hydrogen atoms buried underground. The ice isn't sitting around in convenient blocks, waiting for us to harvest it either. It's mixed into the soil like chocolate chips in cookie dough, sometimes starting just inches below the surface. In some polar regions, you could literally dig with a shovel and hit pure ice. But here's what makes this discovery absolutely mind-blowing. This isn't ancient ice from billions of years ago. Some of it formed relatively recently, when Mars's axis tilted differently, causing dramatic climate shifts. The planet has been playing freeze tag with its water for millions of years. The best part? This ice is distributed almost everywhere, not locked away in impossible to reach locations. Future Mars colonists won't need to trek to the poles for a drink of water. Speaking of location, Mars has some pretty specific places where this ice becomes even more interesting. Picture this. Mars has been playing with lava longer than Earth has even existed as a solid planet. We're talking about volcanic activity that lasted roughly 4 billion years. That's not a typo. While Earth's volcanoes come and go, getting recycled by our restless plate tectonics, Mars decided to be the ultimate overachiever. The planet just kept building the same volcanoes higher and higher, and higher. Here's what's wild. Mars doesn't have moving crustal plates like we do. So when a volcano started erupting, it stayed put for millions of years, sometimes hundreds of millions of years. The lava just kept piling up in the exact same spot, like the world's most patient construction project. Think about Olympus Mons again. That monster didn't appear overnight. It took somewhere between 100 million and 2 billion years to reach its current height. That's longer than complex life has existed on Earth. But here's where it gets really interesting. The volcanic activity wasn't random. Mars had distinct periods of volcanic fury, followed by long, quiet spells. The early volcanic period was absolutely bonkers, reshaping entire hemispheres with flowing lava. Even more fascinating, some Martian volcanoes might still be technically active today. They're just taking a really, really long nap. Which brings us to something that'll blow your mind about how these ancient lava flows created something unexpected. Picture trying to navigate when you can't see your own hand in front of your face. That's exactly what happens during Mars' most terrifying weather phenomenon. When global dust storms hit Mars, they don't mess around. These planetary tantrums can block out the sun so completely that solar-powered equipment becomes completely useless for months at a time. We're talking about storms that make Earth's worst hurricanes look like a gentle breeze. The most recent monster storm, in 2018, lasted nearly 4 months. It covered the entire planet in a thick blanket of dust that turned day into night. The poor Opportunity rover, which had been exploring Mars for 15 years, finally met its match when this storm drained its batteries completely. But here's what makes these storms truly bizarre. They can start from absolutely nothing. One day, Mars looks perfectly clear, and within weeks, the entire planet disappears under a dust cloud thicker than London fog. The storms feed on themselves, growing larger as more dust gets kicked up into the atmosphere. These dust devils from hell can reach temperatures that would make your oven jealous, spinning at speeds that would terrify any tornado chaser. The worst part? Once they start, there's absolutely no way to predict when they'll stop. Speaking of Mars's dangerous environment, the planet holds some radioactive secrets beneath its rusty surface that would surprise you. Mars isn't just sitting there harmlessly in space. The red planet is actually slightly radioactive, thanks to naturally occurring uranium, thorium, and potassium scattered throughout its rocks. Now, before you panic about future Mars colonists glowing in the dark, we're talking about background levels similar to what you'd find in granite countertops or certain beaches on Earth. But here's where it gets really interesting for future Mars missions. This natural radioactivity could actually be a gold mine for power generation. Radioisotope thermoelectric generators, or RTGs, have already powered Mars rovers for years using plutonium from Earth. Well, Mars might have enough natural radioactive materials to power entire colonies without shipping nuclear fuel from home. The Curiosity rover detected these radioactive signatures using its onboard instruments, essentially giving Mars a geological X-ray. Some regions show higher concentrations than others, which means future colonists might want to avoid certain neighborhoods. Or maybe they'll build their nuclear power plants there instead. Then there's the bonus feature nobody talks about. These radioactive elements help scientists date Martian rocks and understand the planet's formation timeline. It's like Mars came with its own built-in geological clock, ticking away for billions of years. Speaking of ticking clocks, Mars has another surprising feature that affects time itself. The planet's crust holds secrets about its internal structure that would shock you. The Martian crust runs about 25 miles thick on average. That's roughly twice as thick as Earth's oceanic crust and comparable to our continental crust. But here's what makes this fascinating. Mars achieved this thickness through completely different processes than our planet. Earth's crust stays relatively thin because of plate tectonics. Our continental plates constantly move, collide, and recycle themselves back into the mantle. It's like having a conveyor belt that keeps things fresh and prevents any single section from getting too thick. Mars? Well, it missed that geological memo entirely. Without plate tectonics, the Martian crust just kept building up layer after layer. Think of it like making a really thick pancake. You keep pouring batter on top, but the bottom layers never get flipped or moved around. Over billions of years, volcanic activity and impact debris just accumulated into this massive rocky shell. This thick crust acts like a giant insulating blanket. Heat from Mars's interior gets trapped underneath, which explains why some volcanic regions stayed active for so incredibly long. Olympus Mons didn't grow to ridiculous heights by accident. That thick crust kept the magma cooking below. The extra thickness also means Mars experiences far fewer Marsquakes compared to Earth's constant seismic activity. But speaking of what lies beneath this thick rocky layer, Mars didn't just have one ocean that disappeared overnight. The red planet actually had multiple sea levels throughout its ancient history, like a bathtub that kept getting drained and refilled over millions of years. Picture walking along what looks like random ridges and terraces scattered across the Martian landscape. Well, those aren't random at all. They're ancient beach lines from when Mars had oceans at different depths. Some shorelines sit high up on crater rims, while others snake through valleys thousands of feet below. The most famous is the Arabia shoreline, which wraps around Mars like a belt. Scientists think this marked the edge of an ocean that covered nearly a third of the planet. But here's where it gets wild. There's evidence for at least 3 different ocean levels, suggesting Mars went through repeated cycles of flooding and drying. Each shoreline tells a different chapter in Mars's climate story. The highest ones formed when the atmosphere was thick and warm enough to support massive bodies of water. Lower shorelines represent later periods when the planet was already losing its grip on liquid water. These ancient beaches even show wave-cut patterns and sediment deposits, just like Earth's coastlines. Some of these watery periods might have lasted millions of years, plenty of time for life to potentially take hold. But Mars wasn't done playing tricks with physics yet. When rocks from Mars land in your backyard, they're carrying stories older than any dinosaur that ever walked Earth. These Martian meteorites didn't just hop over yesterday. They've been traveling through space for millions of years after getting blasted off the red planet by massive asteroid impacts. The oldest of these space travelers clocks in at around 4.5 billion years old. That's seriously ancient. We're talking about rocks that formed when our solar system was basically a cosmic toddler, stumbling around and figuring things out. But here's what blows my mind. These meteorites are essentially free Mars samples delivered right to our doorstep. Scientists have found over 300 confirmed Martian rocks on Earth, and each one is like getting a geology textbook written in stone. They tell us about Mars's volcanic history, its atmosphere, and whether water once flowed across its surface. The crazy part? These rocks survived getting launched into space at 25,000 miles per hour, drifting through the cosmic void for eons, then screaming through Earth's atmosphere at blazing speeds. Talk about a rough commute. Each meteorite is basically a time capsule, preserving secrets about what Mars was like billions of years ago. Speaking of preservation, there's something even more remarkable about how Mars keeps its ancient features intact. Looking at Mars from space, you'd think those weird geometric shapes scattered across the South Polar region were some kind of alien artwork. These aren't your typical craters or valleys, though. Scientists call them areniform terrain, but honestly, they look exactly like giant spiders sprawled across the Martian surface. Each spider can stretch over half a mile wide, with dozens of channels radiating outward like legs from a central body. The resemblance is so uncanny that even seasoned researchers can't help but chuckle when they first see the satellite images. But here's what's actually happening down there. Every Martian spring, carbon dioxide ice that's been frozen solid all winter starts sublimating directly into gas. This process creates incredible pressure underneath the ice sheet, eventually carving out these intricate channel networks as the gas escapes. The whole thing works like a natural pressure cooker. Gas builds up, finds weak spots, then bursts through in explosive jets that can shoot hundreds of feet into the air. Over thousands of years, this seasonal process has carved these spectacular spider-like formations into the landscape. What makes this even more fascinating? Earth has absolutely nothing like this. Our planet simply doesn't have the right combination of atmospheric pressure and seasonal temperature swings to create such phenomena. Speaking of unique atmospheric conditions, Mars has another layer of surprises floating high above these polar spiders. Mars has an invisible electric layer high above its surface called the ionosphere, and it behaves like a moody teenager having an absolute meltdown. One day, it's thick and stable. The next, it's practically gone. Unlike Earth's ionosphere, which stays relatively consistent thanks to our protective magnetic bubble, Mars gets the full brunt of solar radiation without any shields up. When the sun decides to have a particularly energetic day, it bombards Mars with charged particles that can make the ionosphere swell to 10 times its normal thickness. Then, just as quickly, it can shrink back down to almost nothing. This creates a nightmare for mission planners trying to communicate with rovers and orbiters. Radio signals that worked perfectly yesterday might bounce around like ping pong balls today, or disappear entirely into the cosmic void. The European Space Agency learned this the hard way when they temporarily lost contact with their Mars Express orbiter during an unexpected ionospheric surge. But here's where it gets really wild. The ionosphere doesn't just change randomly. It pulses with the Martian seasons. During dust storm season, all that charged dust flying around acts like a giant electrical generator, supercharging the upper atmosphere. Even stranger? Scientists recently discovered the ionosphere has holes that open and close like trapdoors, allowing atmosphere to leak into space. Speaking of atmospheric mysteries, wait until you discover what ancient minerals buried in Martian soil reveal about the planet's watery past. Clay minerals on Mars tell one of the most compelling stories about the red planet's ancient past. These microscopic crystals can only form in the presence of liquid water, making them like geological detectives that reveal secrets from billions of years ago. When rovers and orbiters discovered extensive clay deposits across Mars, they essentially found proof that our neighboring planet once had conditions suitable for life. Think about it. Clay formation requires not just water, but stable water that sticks around for thousands of years. You can't make clay from a quick splash. The really exciting part? These clay minerals formed during what scientists call the Noachian period, roughly 3.5 to 4 billion years ago. During this time, Mars had a thicker atmosphere and much warmer temperatures. Rivers flowed, lakes filled crater basins, and chemical reactions happened at a pace that could support living organisms. What makes Martian clay even more fascinating is its incredible preservation. Unlike Earth, where plate tectonics and weather constantly reshape the surface, Mars acts like a planetary time capsule. These clay deposits have been sitting there, virtually unchanged, waiting to tell their story. Rovers have found different types of clay minerals scattered across the planet, each revealing different chapters of Mars' watery past. But there's something else hiding in Martian rocks that makes the case for ancient life even stronger. Picture Mars as a giant chemistry set scattered across an entire planet. Every region tells a completely different story through its soil composition. The northern plains? They're packed with basaltic minerals from ancient volcanic activity. Meanwhile, the southern highlands contain feldspar-rich rocks that whisper tales of a much older Mars. But here's where things get wild. Some areas have soil so salty it could preserve meat for decades. Other regions contain enough sulfur to make your nose wrinkle from millions of miles away. The Curiosity rover discovered spots where the dirt is practically edible. Well, if you ignore those pesky toxic perchlorates we mentioned earlier. Then there's the iron content variations. Some Martian dirt is basically rust heaven, while other patches contain enough olivine to make geologists weep with joy. It's like Mars couldn't decide what kind of planet it wanted to be, so it chose everything. The practical implications? Future Mars colonists can't just plop down anywhere and expect the same resources. Want to make concrete? Better check your local calcium levels first. Planning a metal workshop? Hope you landed near those iron-rich deposits. Different regions even have varying levels of water locked in their soil. Some spots are bone dry, while others are practically mud waiting to happen. Speaking of Mars mysteries, wait until you hear about the tiny glass spheres scattered across the surface. Picture this. You're walking on Mars and stumble across what looks like tiny blueberries scattered across the rusty landscape. Except these aren't fruit. They're natural glass spheres called hematite concretions that tell an incredible story about ancient Mars. NASA's Opportunity rover discovered these marble-sized treasures in 2004, and honestly, they were puzzling at first. These perfectly round, dark spheres were just sitting there in the dirt, like someone had spilled a bag of metallic marbles. But here's what makes them absolutely fascinating. They only form in one specific way: water, lots of it. These blueberries are actually made of hematite, an iron oxide mineral that crystallizes when water slowly evaporates from iron-rich solutions underground. Think of them as nature's time capsules, preserving evidence of ancient Martian hot springs and underground water systems that existed billions of years ago. The formation process is remarkably slow and patient. Water seeps through rock, carrying dissolved iron. Over thousands of years, the iron gradually concentrates and hardens into these perfect spheres. It's like geological bubble making, but with metal instead of soap. What's mind-blowing is their abundance. Opportunity found fields of them stretching across entire crater floors. Each tiny sphere represents a moment when Mars was warm and wet enough to support flowing water for extended periods. But Mars holds even stranger magnetic secrets in its crust that reveal surprising truths about its violent past. The Martian magnetic field has stripy patterns that look like a cosmic barcode. While Earth has one big magnetic field wrapping around the whole planet, Mars has these weird magnetic stripes scattered across its surface, like someone took a giant magnet and dragged it through clay. These stripes tell an incredible story. Billions of years ago, Mars actually had a global magnetic field just like Earth's. But then something catastrophic happened. The planet's core started cooling down, and that protective magnetic bubble just vanished. Here's where it gets wild. Before the magnetic field died completely, Mars was doing something that blows scientists' minds. The planet was actually practicing plate tectonics. You know how Earth's continents drift around. Mars was doing that too, way back in the day. As the Martian surface moved around, it recorded the magnetic field direction in its rocks, creating these permanent magnetic stripes. Think of it like a geological recording studio, where the planet was laying down tracks of its magnetic history. The really weird part? These magnetic stripes are strongest in Mars's southern hemisphere. They're like fossil magnetism, preserved for 4 billion years. When solar wind hits these magnetic patches today, it creates mini magnetic shields that deflect charged particles in specific spots. But Mars isn't done surprising us with its atmospheric secrets. Mars acts like a giant chemical laboratory that changes its recipe with the seasons. While Earth's atmosphere stays pretty much the same year-round, Mars throws a complete atmospheric makeover party every few months. The most dramatic change happens with water vapor. During Martian summer, the atmosphere can hold up to 10 times more water vapor than in winter. That's like the difference between breathing in the Sahara Desert versus standing next to Niagara Falls. Well, if Niagara Falls were made of incredibly tiny water molecules floating around. But here's where it gets really wild. Methane levels spike and disappear like a cosmic game of hide and seek. Scientists detect methane bursts during certain seasons, then poof, It vanishes faster than cookies at a bake sale. This seasonal methane mystery has researchers scratching their heads because it might indicate active geology or even microbial life burping underground. Carbon dioxide plays the biggest seasonal drama queen role. During winter, so much CO2 freezes at the poles that the entire planet's atmospheric pressure drops by 25%. It's like Mars is literally breathing, inhaling, and exhaling its atmosphere with each season. Temperature swings trigger chemical reactions that wouldn't happen otherwise. Some compounds only form during specific seasons, creating a constantly shifting atmospheric cocktail that makes Mars unpredictable. Speaking of unpredictable changes, Mars holds secrets about multiple wet periods hidden in its ancient rocks. Martian rocks are like history books written in stone, and they tell an incredible story of water coming and going across millions of years. But here's what makes this discovery mind-blowing. These aren't just traces of one ancient wet period. We're talking about multiple chapters of Mars being soaked, dried out, then soaked again. The evidence sits right there in the rock layers. Different types of minerals form under wet conditions versus dry ones, and Mars rocks show this back and forth pattern repeating over and over. It's like finding evidence that your basement flooded, dried up, flooded again, then dried up 20 more times. What's wild is the timeline. These wet and dry cycles happen across hundreds of millions of years. That's not just a quick splash of water here and there. That's sustained periods where liquid water existed on the surface, disappeared for ages, then somehow returned. Think about what this means for life. On Earth, life adapts to changing conditions. Microbes go dormant during tough times and spring back when conditions improve. If Mars had similar cycles, any early life forms would have had multiple opportunities to evolve, adapt, and potentially survive. The rock chemistry doesn't lie either. Clay minerals, salt deposits, and rust formations all point to these repeating water cycles. But here's something that'll really mess with your head about Mars. Hidden beneath Mars' middle latitudes lie massive underground ice glaciers that would make Antarctic explorers jealous. These aren't tiny ice patches we're talking about. We're dealing with frozen water deposits stretching for hundreds of miles underground, some as thick as city skyscrapers. Scientists discovered these buried treasures using radar that can peek beneath the Martian surface like an X-ray machine. The ice sits there, perfectly preserved, waiting like a cosmic freezer that's been running for millions of years. What's wild is that this ice formed during completely different climate periods when Mars had a thicker atmosphere. These glaciers got buried under layers of dust and rock over time, creating natural refrigerators. The dust acts like insulation, keeping the ice from sublimating away into the thin atmosphere. It's like Mars wrapped its water supplies in protective blankets. For future astronauts, these glaciers are basically giant underground water tanks scattered across the planet. You could literally drill down and hit fresh water ice in regions that look bone dry from the surface. No need to haul water from Earth when Mars already stockpiled it for you. The best part? These deposits exist in zones where humans might actually want to live, not at the freezing poles, but in more moderate latitudes. But even with all this buried ice, the Martian surface itself tells an even more dramatic story about how meteorites have been reshaping this world. When you think about soil formation on Earth, you picture plants decomposing and rocks slowly weathering over time. Well, Mars took a completely different approach to creating its dirt. The red planet has been getting its surface literally pounded and mixed by space rocks for billions of years. This cosmic gardening process is actually fascinating. Every time a meteorite crashes into Mars, it doesn't just create a crater and call it a day. Nope. The impact explosion sends chunks of rock flying for miles, mixing different materials together like some violent planetary blender. The force is so intense that rocks from deep underground get tossed around and mixed with surface dust. What's really wild is how thorough this mixing has been. Scientists estimate that the top layer of Martian soil has been churned and rechurned countless times. It's like having an incredibly patient but destructive gardener working for 4 billion years straight. No wonder Martian soil composition is surprisingly uniform across vast distances. The meteorites themselves also contribute ingredients to this cosmic soup. Iron from space rocks adds to the rusty color we see. Rare elements get scattered around. Some impacts even bring organic compounds from asteroids or comets. This ongoing bombardment explains why Mars has such fine, powdery soil everywhere. But here's something even stranger about Martian dirt. Mars holds geological treasures that tell an incredible story about its watery past. Hidden throughout the planet's ancient rocks are carbonate deposits. Basically limestone formed when carbon dioxide dissolved into vast Martian oceans billions of years ago. Think about how seashells form on Earth when marine creatures pull carbon from seawater. Mars did something similar, but without the cute sea creatures. The planet's early atmosphere was so thick with carbon dioxide that when it mixed with liquid water, it created these mineral deposits naturally. Here's what blows my mind. These carbonates suggest Mars once had atmospheric pressure at least 5 times thicker than today. That's dense enough to keep liquid water stable on the surface for millions of years. We're talking about oceans that could have lasted longer than complex life has existed on Earth. The carbonates act like geological time capsules. Each layer records atmospheric conditions when it formed. Some deposits show evidence of hot springs and hydrothermal activity, perfect conditions for early life to potentially flourish. But here's the puzzle. We haven't found nearly as many carbonates as we should have, given how thick that early atmosphere was. Most of Mars's carbon dioxide vanished somewhere along the way. Speaking of vanishing acts, there's another mystery brewing on Mars that involves electricity powerful enough to fry your smartphone. Ever wondered why Mars missions lose so many electronics? Well, Martian dust isn't just annoying, it's downright dangerous. This incredibly fine powder builds up static electricity that would make your hair-raising sock-on-carpet experiments look like child's play. The dust particles are smaller than talcum powder, and when they rub against each other during those massive dust storms, they create electrical charges that can fry sensitive equipment faster than you can say, mission failure. We're talking about static buildups, powerful enough to damage computer circuits and communication systems. But here's where it gets wild. The thin Martian atmosphere actually makes this problem worse, not better. On Earth, our thick atmosphere helps dissipate electrical charges. Mars? Not so much. The dust just keeps building up charge until it finds something electronic to zap. NASA engineers have had to completely redesign equipment just to handle this invisible threat. They've added special grounding systems and protective coatings, but dust still finds ways to sneak in and cause havoc. It's like trying to protect your laptop from invisible lightning bolts. The Opportunity rover, actually experienced several of these electrical events during its mission. Some dust devils helped clean its solar panels, while others nearly fried its systems. Talk about a love-hate relationship with Martian weather. Speaking of dust, creating unexpected problems, wait until you hear about Mars's hidden underground water networks. Beneath Mars's frozen surface, networks of salty underground rivers might be flowing right now. These aren't your typical freshwater streams. They're loaded with perchlorates and other salts that work like antifreeze, keeping water liquid even when temperatures drop to minus 60 degrees Fahrenheit. Scientists discovered these hidden brine networks using ground-penetrating radar and careful analysis of seasonal surface changes. The salt concentration is so intense that these underground flows would taste worse than seawater mixed with cleaning chemicals. But here's what gets exciting. Some microbes on Earth absolutely love these harsh, salty conditions. These subsurface waterways could stretch for miles beneath our feet, creating an entire hidden ecosystem we've never seen. The brines stay liquid by traveling through porous rock layers and soil, protected from the brutal surface conditions above. Think of it like Mars has its own underground plumbing system that's been running for millions of years. The really wild part? Some of these brine flows might connect to those mysterious dark streaks we see appearing on crater walls during warm seasons. That means Mars could have active water circulation happening right now, not just frozen relics from the ancient past. The salt levels would kill most Earth life instantly, but extremophile bacteria might find these underground rivers absolutely perfect. But speaking of things that would definitely kill you on Mars, getting off Mars would be like playing space travel on easy mode. The escape velocity is only 11,000 miles per hour compared to Earth's brutal 25,000. That's less than half the speed needed. What does this mean for future Mars colonists? Well, launching a rocket from Mars requires way less fuel than blasting off from Earth. Think about it like jumping out of a swimming pool versus jumping out of a deep well. Mars barely holds on to things compared to our planet's gravitational grip. This changes everything for return missions. NASA engineers are practically drooling over these numbers because they mean smaller rockets, lighter fuel loads, and way cheaper trips home. A spacecraft that would need massive fuel tanks on Earth could practically hop off Mars with a gentle push. But here's the really wild part. This low escape velocity is exactly why Mars lost its atmosphere in the first place. The planet just couldn't hold on to its air molecules tight enough. Solar winds kept stripping them away, bit by bit, over billions of years. For future space travelers, though, this weakness becomes a strength. Imagine setting up a launch facility on Mars that could send supplies back to Earth or out to the asteroid belt. It would be like having a cosmic gas station with bargain prices. Speaking of Mars losing its grip on things, wait until you hear about the ancient underwater volcanoes that once bubbled beneath Martian seas. Deep beneath ancient Martian oceans, something incredible was happening. Hydrothermal vents were pumping scalding water rich with minerals and chemicals into the dark depths. These underwater volcanoes created perfect conditions for life to emerge. Here's what makes this mind-blowing. These vents operated for hundreds of millions of years. That's longer than complex life has existed on Earth. The constant flow of heated, mineral-rich water provided exactly what early life forms need: energy, warmth, and chemical building blocks. Scientists have found compelling evidence of these ancient underwater hot springs scattered across Mars. The telltale signs? Distinctive mineral deposits that only form when hot water meets cold ocean water. It's like finding the recipe book for life written in stone. But here's the wild part. These vents didn't just exist randomly. They were perfectly positioned in areas where the ocean was deep enough to remain liquid for extended periods. The chemistry was spot on too, with sulfur compounds and iron minerals creating an energy buffet for primitive microbes. On Earth, hydrothermal vents still harbor some of our planet's most extreme life forms. These creatures thrive in boiling water without sunlight, proving life can flourish in seemingly impossible conditions. The evidence suggests Mars had thousands of these biological factories operating simultaneously. However, Mars wasn't just reshaping its own geology through these processes. Mars literally changes shape throughout the year. And no, this isn't some weird space magic. It's actually happening right now as you listen to this. The planet's atmosphere has a mass of about 16 trillion tons. That's a lot of weight floating around up there. During winter, massive amounts of carbon dioxide freeze out of the atmosphere and pile up at the poles as dry ice. We're talking about roughly 25% of the entire atmosphere just disappearing. All that atmospheric mass has to go somewhere. So it becomes solid and sits at the poles like a giant frozen blanket. This redistribution of mass actually changes Mars's gravitational field in measurable ways. The planet becomes slightly less round and more, well, let's call it potato-shaped. When spring arrives, all that frozen carbon dioxide sublimates back into gas and rejoins the atmosphere. Mars literally inflates back to its normal shape. It's like watching a balloon deflate and reinflate, except the balloon is an entire planet. This shapeshifting creates serious headaches for mission planners. Spacecraft orbiting Mars have to constantly adjust their navigation systems because the planet's gravitational field keeps shifting beneath them. GPS on Mars, good luck with that. The mass redistribution even affects Mars's rotation slightly, making days fractionally longer or shorter, depending on the season. But Mars has even stranger acoustic properties that'll make you question everything you know about sound. Mars has some of the most incredible sand dunes you'll ever see. But wait until you hear this. They actually make music when the wind hits them just right. These aren't your typical beach dunes. Martian dune fields stretch for hundreds of miles across the planet's surface, creating landscapes that look like frozen ocean waves. The dunes near Mars' North Pole are particularly stunning, with some reaching heights of several hundred feet. When strong winds sweep across these massive sand formations, something magical happens. The grains of sand start vibrating against each other, creating low-frequency sounds that travel through the thin Martian atmosphere. It's like the planet is humming a mysterious tune. Earth has singing dunes too, but Mars takes it to another level. The dry conditions and unique grain size make the acoustic effects even more pronounced. Some researchers think these sounds could reach volumes comparable to a loud conversation, though the thin atmosphere means they wouldn't travel very far. The wind patterns that create these sounds also constantly reshape the dunes themselves. Satellite images show these formations migrating across the surface over time, like slow-motion dancers performing an eternal ballet. What makes this even more fascinating is how the sound waves might interact with Mars's unusual atmospheric conditions. But speaking of atmospheric mysteries, there's something even stranger hiding in the planet's ancient rocks. Mars is basically a time capsule sitting right next door to us. While Earth has been constantly reshaping itself through plate tectonics, volcanism, and erosion, Mars hit the pause button about 3 billion years ago. The result? A planet that preserves ancient secrets from when our solar system was just getting started. Think about it. When astronomers study Mars rocks, they're literally looking at materials that witnessed the solar system's violent birth. The massive impact craters scattered across the Martian surface tell stories of the late heavy bombardment, a period when asteroids and comets were basically playing cosmic pinball with every planet in sight. Earth got hit just as hard, but our planet erased most of that evidence through geological recycling. But here's where Mars becomes absolutely fascinating for understanding our cosmic neighborhood. The planet's ancient rocks contain isotope ratios that match meteorites formed during the solar system's earliest days. These chemical fingerprints reveal how the sun's stellar winds shaped planetary atmospheres, how water got distributed throughout the inner planets, and even how the gas giant planets migrated to their current positions. Mars essentially froze in time, preserving evidence that everywhere else got destroyed or buried. It's like having a museum of solar system history just waiting to be explored. Speaking of time preservation, Mars may have been playing host to something extraordinary for much longer than anyone expected. When we talk about life on Mars, most people think about little green men or Hollywood aliens. But the real story is way more incredible than fiction. Mars may have actually supported life for 1.5 billion years. That's not a typo. Billion with a B. Think about this for a second. Earth has had life for roughly 3.5 billion years. Mars potentially had habitable conditions for almost half that time. We're talking about a window that stretches longer than complex life has existed on our planet. The evidence keeps piling up from multiple missions. Ancient lake beds, flowing rivers, hydrothermal vents, and underground water systems all point to the same conclusion. Mars wasn't just briefly wet, it stayed wet for an incredibly long time. But here's what blows my mind. 1.5 billion years is enough time for evolution to work its magic. On Earth, that's the difference between simple bacteria and complex organisms. If life did get started on Mars, it could have evolved into something pretty sophisticated. The overlap periods are particularly fascinating. While Earth was still figuring out how to make oxygen, Mars might have been hosting its own biological experiments. Two worlds, developing life simultaneously, just 35 million miles apart. However, Mars holds one more surprise that might change everything we think we know about the red planet. Mars continues to surprise scientists with new discoveries every year. And honestly, that's what makes this planet so absolutely fascinating. Just last year, researchers found evidence of active volcanism that might still be happening today. We're talking about lava flows that could be younger than some of your favorite TV shows. Then, there's the discovery of seasonal methane burps that appear and vanish like cosmic hiccups. Nobody knows exactly what's causing them, but the possibilities are mind-blowing. The Perseverance rover keeps finding organic molecules in rocks that formed when Mars had lakes and rivers. Each sample tells a story we're still learning to read. Meanwhile, the InSight lander detected Marsquakes that revealed the planet's core is actually larger and more liquid than we expected. But here's what really gets me excited. We're finding water everywhere we look. Underground lakes, seasonal flows, ice glaciers buried beneath dust. Mars is basically a frozen water world hiding in plain sight. Future missions will drill deeper, fly helicopters across alien landscapes, and maybe even bring Martian rocks back to Earth. The James Webb Space Telescope is already changing how we see Mars from space. Every answer we find creates 10 new questions. And that's exactly why Mars remains humanity's greatest planetary mystery, a world that keeps rewriting its own story.